It came, and then it vanished. A ghost, drifting through the void. For years, astronomers gazed at Fomalhout B, a massive exoplanet orbiting a bright star 25 light-years away. They called it the zombie planet. Why? Because it wasn't behaving like anything they'd ever seen. First captured by the Hubble Space Telescope in 2008, it shimmered strangely, like light through fog. But by 2014, it was gone. No orbit, no planet, nothing. What happened? Some say it was never a planet at all, just the glowing wreckage of a massive collision, a cosmic car crash, flaring briefly in the dark before fading forever. Others believe it was a mirage, a trick of light, proof that space still holds secrets too big for us to grasp. Fomalhout B didn't just disappear, it reminded us. In this universe, even giants can vanish without a trace. If you've ever stood under a clear night sky, far from the glow of cities, you've probably looked up in wonder, maybe even tried to pick out a few of the brighter stars. And if you happen to be gazing south, sometime in late autumn, you might have noticed a sharp, bluish point of light, bright, steady, and alone. That's Fomalhaut. It's not the most famous star in the sky. It doesn't sparkle in constellations like Orion or blaze overhead like Sirius. But Fomalhaut is special, quietly brilliant, and full of secrets. It sits about 25 light-years away from Earth, which, in cosmic terms, is practically next door. If space were a neighborhood, Fomalhaut would be a distant house at the end of your street. Still out of walking range, but close enough to keep an eye on. Light, traveling at 186,000 miles per second, takes just 25 years to reach us from there. So when we see Fomalhaut in the sky tonight, we're looking at the star as it was back in the year 2000. It's the brightest star in the small, often overlooked constellation Piscis Austrinus, the southern fish. Fomalhaut itself is sometimes called the mouth of the fish, from the Arabic Fomalhaut. You won't find a dazzling fish shape up there, just a single bright star hanging below Aquarius all by itself, like a jewel on a chain. But while it might seem like a lone sparkle in the sky, there's a lot more going on. From Earth, Fomalhaut appears pristine and calm. Through the lens of a backyard telescope, it looks like any other bright point of light. But behind that shine is a star far more massive and much younger than our Sun. Fomalhaut is an A-type main sequence star, about twice as big and 16 times as luminous. It's still early in its life, around 440 million years old, compared to the Sun's 4.6 billion years. That brightness isn't just for show, it hints at the kind of energy pouring out from this star. More ultraviolet light, more intense radiation, and more gravitational pull. Fomalhaut burns hotter, lives faster, and will die younger than the Sun. And it's not alone. Around Fomalhaut stretches a vast, mysterious structure, a ring of dust and ice, similar to our solar system's Kuiper belt, but far more dramatic. Think of it as a cosmic hula hoop, orbiting the star at tens of billions of kilometers. It's cold, dark, and filled with debris, chunks of rock and ice left over from the star's chaotic early days. Imagine the aftermath of a massive construction site in space. The planets are built, or maybe in the process of being built, and what's left behind is this ring of leftover materials, circling in silence. It's this ring that makes Fomalhaut so fascinating to astronomers. It's highly structured, not just a random cloud of dust. It's sharply defined, almost sculpted, as if something large, perhaps a planet, was shaping it with its gravity. That's how scientists often discover exoplanets, not by seeing the planet itself, but by noticing how it pushes things around. Here on Earth, we first got serious about Fomalhaut in the early 2000s. Observatories across the globe, along with the Hubble Space Telescope, began peering closely at the star, especially in infrared light, perfect for spotting warm dust and the faint glow of distant objects. And what they found was captivating. This wasn't just another star with a boring, hazy disk of debris. Fomalhaut's ring was crisp, bright, and tilted just right for us to see its entire structure. It looked almost like Saturn's rings, only 20 billion kilometers wide. To put that in perspective, if our solar system were the size of a dinner plate, Fomalhaut's ring would be a full hula hoop circling around it, icy, ancient, and just slightly off-kilter. But Fomalhaut's intrigue doesn't stop at its physical beauty. There's something about the way it stands out in the sky. Even to ancient skywatchers, Fomalhaut seemed different. It was one of the 4 royal stars in Persian astronomy, stars that were said to guard the heavens from the 4 corners of the sky. Fomalhaut was the watcher of the south, marking the end of summer and the beginning of darker seasons. To early civilizations, it was tied to water, to floods, and to transition. Its solitary position in the southern sky gave it a sense of quiet mystery, almost as if it didn't belong to any group, just a lone sentry glowing through the ages. And it's in this stillness, this quiet remoteness, that modern science started paying attention. Not because Fomalhaut is the closest or the biggest star, but because of what surrounds it, and what might be lurking just inside that massive dust ring. You see, stars like Fomalhaut are the perfect places to go exoplanet hunting. They're bright enough to light up surrounding dust, but distant and stable enough to allow subtle changes to be tracked over time. So when Hubble turned its gaze toward Fomalhaut in 2004, scientists weren't just expecting to see a beautiful ring. They were hoping to see signs of something else, something moving, something shaping the chaos. And then they did. A tiny speck, a flicker in the dark, slowly shifting, orbiting. At first, it didn't seem like much, but over the next few years, it became clear. This was something real, something big. The light from it wasn't quite right. It wasn't glowing from heat like a typical planet. But it was there. They named it Fomalhout B, and it was hailed as one of the first directly imaged exoplanets in human history. Not just a signal or a graph, but an actual image. A planet, seen through the eyes of a telescope, circling a star 25 light-years away. But the story didn't end there, because what Fomalhaut gives with one hand, it often takes away with the other. And it was here, in this quiet system 25 light-years away, that something strange appeared. Fomalhaut is a name that sounds like wind sweeping over alien dunes, or the echo of light glinting off the surface of something ancient and half-remembered. And in a way, that's not far off. It's a star, yes, but it's also a setting, a stage, a spotlight cast across a stretch of interstellar silence, illuminating something extraordinary. 25 light-years away in the constellation Piscis Austrinus, Fomalhaut sits like a glowing eye staring out from the southern sky. Invisible light, it's bright, bold, a white star pulsing with youth and energy. But it wasn't just its brightness that drew astronomers in. It was what surrounded it, what circled it, that made Fomalhaut a story worth telling. Because wrapped around this lonely sun was something we don't often see. A perfect ring of cosmic dust, a dusty halo, a ghostly echo of creation. Imagine a cosmic vinyl record, wide, precise, and ancient. That's Fomalhaut's debris disk. It stretches out more than 20 billion kilometers, or about 140 astronomical units from the star, far beyond the orbit of Pluto in our own solar system. And unlike the messy, irregular belts of other stars, this one is nearly pristine. A sharp-edged ring like someone had taken a blade to the cosmos and carved a groove around a star. It's cold out there. Incredibly cold. The dust particles that make up the ring are frozen, drifting through an ocean of nothingness at temperatures that would freeze nitrogen solid. But they're not still. These tiny fragments, remnants of collisions between asteroids, comets, and perhaps once planets, are constantly moving, slowly stirred by invisible hands, gravity, radiation pressure, and the leftover chaos of planetary formation. And what made it so beautiful to astronomers wasn't just its size or symmetry, it was the mystery it implied. Debris disks are, in essence, cosmic breadcrumbs, traces of what once was or what might still be. They're the aftermath of world-building events, violent, creative, chaotic. When stars form, the leftover dust and gas around them doesn't just vanish. It coalesces, it spins. Some of it forms planets, some of it doesn't. And what doesn't often gets scattered into a ring. But here's the thing. Rings don't just happen. They're sculpted, shaped, shepherded. Just like Saturn's rings are gently held in place by its moons, pulling here, pushing there, astronomers believe that the sharply defined edges of Fomalhaut's debris disk suggest the presence of gravitational guardians, planets, hidden ones, orbiting silently in the inner shadows, carving the ring with their unseen mass. When the Hubble Space Telescope first captured Fomalhaut's disk in the early 2000s, it wasn't just a technical achievement. It was like peering into another solar system's adolescence. We were witnessing a dusty silhouette of a place where planets may be forming, or had already formed, and where the ghosts of past collisions still danced in orbit. The ring itself has a remarkable shape, slightly off-center from the star, like a planet had tugged it gently to one side. That asymmetry was a clue. Something massive must have been lurking nearby, keeping the dust in check, maintaining the ring's tight structure. And that something, astronomers thought, might be Fomalhout B. It made sense. The shape of the ring, the gravitational nudges, the age of the system, about 440 million years old, young enough to be chaotic, but old enough to have planets wandering among the ruins. Fomalhaut was primed for drama, and we were just catching the opening act. But this ring, this halo, it wasn't just beautiful, it was volatile. Debris disks like Fomalhaut's are living things, in a way, not alive in the biological sense, but in the sense of motion, of transformation. They're the smoke after a celestial fire. They thin out over time. They pulse with the aftermath of ancient impacts. And sometimes, just sometimes, they light up again, briefly, when something enormous smashes into something else and throws up a cloud of light-catching debris. It's like watching the surface of a still lake and seeing ripples. You may not see the stone fall, but you can feel the echo. Fomalhaut's ring was full of ripples, full of clues. To look at this ring is to glimpse the fossil record of a solar system, a museum of ancient violence and unfinished formation. Dust created by destruction swirling around a star like smoke around a candle. It's a cosmic paradox, so quiet, yet forged in chaos. And that, perhaps, is what made it so emotionally magnetic to astronomers. Because it wasn't just science, it was storytelling. The ring hinted at worlds we couldn't see, at collisions we'd missed, at the idea that stars don't just shine, they remember. They carry the scars of what's happened around them. And Fomalhaut, it remembers everything. It remembers the turbulence of its youth, the wreckage of planetary building gone wrong, the comets torn apart, the rocks shattered mid-orbit, and perhaps it remembers a moment when two massive bodies collided in the dark and left behind a glowing phantom we mistook for a world. So we return to this dusty ring as a reminder of everything we almost understood. It held our curiosity, teased us with symmetry, and whispered a lie we thought was a planet. And yet, it never stopped being beautiful. And if this halo is just the residue of cosmic violence, what else lies hidden in the rings of other stars? Or maybe the better question is, what stories are still waiting to be seen before they vanish into dust? If you've ever been drawn to a flickering star on a clear night, wondering about the secrets it holds, Then you'll understand why Fomalhaut captured the collective imagination of astronomers. The story of Fomalhaut isn't just about the star itself, but about the mysteries it holds within its light. It's a tale of what we can see and what we can't. A star like no other, Fomalhaut became a cosmic lighthouse. A star like no other, Fomalhaut became a cosmic lighthouse, guiding astronomers on a quest to understand the hidden forces shaping our universe. Fomalhaut has always been a standout in the night sky. It's bright, a beacon in the vast expanse of space, easy to spot with the naked eye, a lonely sentinel in the southern sky. But it wasn't just its brightness that caught the eye of astronomers. The early 2000s marked a turning point in the way we viewed distant stars. Technological advances were quickly changing the game. Telescopes were becoming more powerful, more sensitive. Space agencies around the world had begun sending missions with unprecedented precision, giving us eyes not just to look at the stars, but to peer inside them, to see the invisible forces at play. Fomalhaut, with its intriguing disk and the possibility of hidden planets within, became a target for some of the most powerful instruments humanity had ever created. One of the key players in this cosmic search was the Hubble Space Telescope. The Hubble had already revolutionized our understanding of distant space objects, and in the case of Fomalhaut, it was like a finely tuned microscope pointing toward the farthest reaches of the galaxy. Through its clear, sharp lens, astronomers were able to capture detailed images of the debris disk, revealing patterns and structures within it that seemed more precise than anything ever seen before. It was like watching a dance in slow motion, each dust particle moving in harmony with something far more massive, far more mysterious. Then came the Spitzer Space Telescope, another monumental leap forward. This infrared powerhouse could peer through the dust that shrouded Fomalhaut's system, revealing details obscured by the star's own brilliant light. In many ways, Spitzer acted as a cosmic detective, using infrared light to uncover the secrets hidden beneath the bright surface. As the telescope focused on the Fomalhaut system, it revealed a structure far more complex than anyone had expected. But the excitement didn't stop there. In 2008, a discovery from the Hubble Space Telescope would turn the world of astronomy upside down. The ring wasn't just a ring, it was evidence of something far more significant. Within it, astronomers identified what seemed to be a planet, or at least a body with the gravitational pull strong enough to shape the disk around it. This was the first tantalizing glimpse of Fomalhout B, a planet that was born not from our imaginations, but from real, tangible data. The potential for discovery seemed endless. With each new observation, the excitement spread across the scientific community. It was a moment of intellectual awakening. The possibility that Fomalhaut, a star so close by, yet so far removed from our understanding, could hold clues to the birth of planets and solar systems. It felt as though we were on the cusp of unraveling some of the universe's oldest secrets. Astronomers around the world saw in Fomalhaut not just a distant object, but a portal into the mysteries of creation itself. The debris disk was more than a feature of a distant star. It was a rare glimpse into the processes that govern the formation of planetary systems. In Fomalhaut, they saw a story unfolding, one that was both timeless and full of surprises. And so, as telescopes continued to peer deeper into the night, Fomalhaut became a focal point for missions, discussions, and theories. With the combined power of Hubble and Spitzer, the star began to reveal its secrets, layer by layer. The world watched as astronomers uncovered patterns in the debris disk, patterns that, just a few years earlier, had been mere speculation. Was the debris ring a natural byproduct of planetary formation? Or was it evidence of something much stranger, a planet hidden within, pulling and pushing the dust around it in ways that scientists were only beginning to understand? It wasn't just the instruments that were exciting, it was the sheer potential of what we could learn. Fomalhaut represented the frontier of knowledge. It was the perfect combination of a bright, visible star and a cosmic puzzle that promised answers to questions we had barely begun to ask. What if Fomalhaut's disk was a model for other, more distant systems we couldn't yet see? Could the birth of planets happen in ways we hadn't imagined, with rings and structures that defied our expectations? As Fomalhaut became the subject of intense study, the excitement built. Each new observation brought with it the promise of more answers, but also more questions. And with those questions came the recognition that our understanding of the universe was still in its infancy. Even the brightest stars held their mysteries. Even the most visible objects could hide profound secrets. Fomalhaut became more than just a star. It became a symbol of the vast unknown that still waits to be discovered. We looked up at that bright speck in the sky, and suddenly it felt a little less distant. It felt like a puzzle we might one day solve. But as we look back now at the disappearance of Fomalhout B, we're left with a lingering thought. What if there's more to the story than we could ever imagine? Could the answers lie not in the stars, but in the dust left behind? What's hidden in the shadow of a ghost planet, waiting to be uncovered? As the 20th century drew to a close, the night sky, long regarded as a vast ocean of stars and silence, was about to open its depths in ways no one could have anticipated. For centuries, humans had gazed up in wonder, wondering if planets existed around other stars, yet we were mostly left with questions that echoed through the void. Could there be worlds out there, silently spinning around distant suns? In the 1990s, scientists finally took the first steps into this uncharted territory. The discovery of the first exoplanet, a planet orbiting a star outside our solar system, became a monumental leap forward in our understanding of the universe. Before this, the very concept seemed like something out of science fiction. But as it often happens in science, imagination collided with reality. In 1995, the first confirmed exoplanet, 51 Pegasi b, was discovered by astronomers Michel Mayor and Didier Queloz. It wasn't just a breakthrough. It was a revolution, marking the beginning of an era where our understanding of the cosmos would be irrevocably changed. The discovery of exoplanets opened the floodgates for an entirely new field of science, and the excitement around the subject grew exponentially. What began with 51 Pegasi b turned into a frenzy of discovery throughout the next decades. By the time we reached the early 2000s, astronomers had confirmed dozens, then hundreds of exoplanets, each one with its own unique properties, strange orbits, and mysterious atmospheres. The hunt for exoplanets was no longer theoretical. It was real. It was happening, and it was unfolding right before our eyes. But beyond just discovering new worlds, exoplanet science began to inspire a deeper question. Could life exist on any of these planets? That question lay at the heart of every telescope that peered into the void, and it was this very question that made Fomalhaut and its surrounding debris disk so intriguing to scientists. Here was a star, not so far away, with a disk of debris, a signpost of planetary formation, a cosmic birth certificate. And it was in this very disk, scientists believed, that there might be a planet, a world, waiting to be discovered. The year 2008 felt like a culmination of years of work, when a mysterious object, later dubbed Fomalhout B, seemed to flicker into view. Imagine the thrill of an astronomer looking through the lens of a telescope, their eyes drawn not to the familiar stars, but to something else, a hint of a world. The evidence was compelling. Fomalhaut, with its dust ring, showed every sign of harboring a planet. And with the rise of advanced imaging techniques, it became clearer that we were on the verge of something extraordinary, a glimpse of a planet, a world outside our solar system, right there, sitting in the distant glow of Fomalhaut. The tools of the trade had evolved significantly by this point. The early 2000s ushered in the era of exoplanet hunting. Armed with new instruments, scientists began to focus not just on the discovery of exoplanets, but also on directly imaging them. No longer was the search just about observing the tiny wobble of a star or waiting for the telltale dimming of light as a planet passed in front. Now, astronomers had the ability to capture the light reflected off distant planets, allowing them to see these worlds for the first time as faint specks against the vast backdrop of space. This ability to image planets directly opened the door to an entirely new kind of search, one that didn't rely on indirect methods but on actual snapshots of distant worlds. Every new image, every new discovery was like a breadcrumb, leading us to answers about the nature of the universe and our place within it. Could we find an Earth-like world? Could we find a world like no other? Could we find a place where life, our life, might one day take root? Fomalhaut, with its sharp debris ring and possible planet, became the poster child for this new era. The fact that such a clear, clean disk of debris existed around a star so close to us felt almost too perfect. There, out in the cosmic dark, was a laboratory of planetary formation, a stellar nursery where planets might be born, just waiting to be discovered. The object at the center of the debris disk, which many astronomers believe to be Fomalhout B, was the great mystery. Was it truly a planet? Or was it something else entirely, an illusion, a fleeting shadow in the vastness of space? As the years passed, the excitement only grew. The next step in the hunt was to push the boundaries of our telescopes even further, to peer deeper into the heart of distant solar systems, to search for Earth-like worlds in the habitable zones of stars. Each discovery seemed to answer one question, but raise 10 more. Were there more Fomalhout Bs out there, lurking in the debris of other distant stars, waiting to be discovered? What would the next great cosmic revelation be? And, most tantalizing of all, could there be life elsewhere in the universe? The hunt for exoplanets had become a race, a pursuit driven not just by curiosity, but by the yearning to answer the oldest question in human history. Are we alone? And in that pursuit, Fomalhout B was a crucial clue, a tantalizing mystery that we were still trying to understand. Yet even as excitement mounted, there remained a nagging question in the back of the minds of astronomers. What happens when a planet disappears from view? Fomalhout B had captured the imagination of scientists, but its sudden disappearance would soon leave them facing a riddle. How could something so clearly present in the data just vanish? And more importantly, what could this tell us about the nature of the cosmos itself? We've spent centuries gazing into the heavens, trying to unlock the secrets of the stars. But in the blink of an eye, everything we thought we knew can slip away, like sand through our fingers. As we look toward the stars, waiting for the next big discovery, we must ask ourselves, in the vast expanse of the universe, how much more are we missing? And what happens when the answers we seek simply vanish before our eyes? But before we look into Fomalhout B's mysterious disappearance, we must first dive deeper into its miraculous discovery. In the early 2000s, the night sky was a quiet witness to something profound, a growing tension between the vastness of space and the relentless curiosity of human beings. For astronomers, it wasn't just about looking up at the stars, it was about finding answers to questions that had been asked for millennia. Are we alone? What other worlds are out there? And perhaps most interesting of all, could there be a planet just beyond our reach, waiting to be discovered? By 2004, astronomers already had their sights set on Fomalhaut. But what truly captured their attention wasn't just the star itself, it was the debris disk surrounding it. And at the heart of this swirling disk, astronomers thought, there was a planet. Not just any planet, but a planet that might offer us a window into the very birth of planetary systems. This was the stuff of science fiction, but it was suddenly real, within our grasp. And so began a period of intense scrutiny. The hunt for Fomalhout B, the planet believed to be hiding in plain sight within this disk, was on. For years, astronomers observed Fomalhaut, their telescopes focused on the same spot, hoping to catch a glimpse of the elusive planet. But unlike most of the exoplanets discovered during this time, those detected through the wobbling motion of their stars or the dimming of light as they crossed in front, Fomalhout B wouldn't reveal itself so easily. The technology of the time was advancing rapidly, yet this celestial mystery seemed to slip just beyond their grasp. Each new observation, each attempt to capture an image only fueled the excitement. There were moments of hope when the data hinted at something, perhaps a planet, perhaps not. But the truth remained elusive, like a shadow dancing just out of reach. For astronomers, it was both thrilling and frustrating. With each passing year, their belief in Fomalhout B grew stronger, but the evidence was still fragmented, still hazy. It wasn't until 2008 that things began to shift. With powerful lenses and advanced imaging techniques, the telescopes could see deeper into space than ever before. The images it sent back were unlike anything seen before. There, in the debris of Fomalhaut's disk, was a point of light. At last, the planet appeared, as though emerging from the darkness itself. It was a small, faint glow, but it was unmistakable. For the first time, astronomers had what they had been searching for, a direct image of Fomalhout B. The announcement sent shockwaves through the scientific community. The discovery of a planet, seen with such clarity, was a triumph not just for the team who made the observation, but for everyone who had dedicated their careers to the search for exoplanets. The announcement felt like the culmination of years of labor, a proof that we could indeed touch the unreachable stars, that the cosmos had finally opened a small door for us to peer inside. But even as the discovery was hailed as a victory, there were still questions. What kind of planet was this? Was it truly a planet, or just a large, strange object caught in the debris disk? Could it support life? The excitement was tempered by the uncertainty of the unknown. What did this faint, glowing light really mean? In the years that followed, as the Hubble images were studied and analyzed, it became clear that Fomalhout B was no ordinary planet. Its orbit was unusual, unlike the nearly circular orbits of most planets in our solar system. It seemed to be moving through the debris disk in an eccentric path, one that suggested it might not have formed in the same way that other planets did. Some theorized that Fomalhout B had been born in the outer reaches of the system and had migrated inward. Others wondered if it was simply a rogue planet, a wandering body that had somehow become trapped in the star's gravitational pull. With each new study, the mystery only deepened. Fomalhout B became a symbol of the unknown, a beacon of discovery and curiosity that sparked debates and questions among scientists. Some hailed it as a new model for planetary formation, while others saw it as a cosmic enigma, a puzzle that didn't quite fit with the models we had built. But one thing was certain. Fomalhout B had become a focal point for astronomers around the world, a mysterious object that beckoned us to learn more. But the tension was always there. As the years went on, the question that lingered in the back of everyone's mind was whether this planet, so clearly visible at one moment, would remain there for long. Could it be that, like so many mysteries before it, Fomalhout B was destined to slip through our fingers once again? Would it remain a ghost, a fleeting image in the fabric of space? The excitement surrounding Fomalhout B was undeniable, but it was also tinged with uncertainty. In those early days, the question was never far from the surface. What happens when a planet is seen, and then it's not? As astronomers trained their telescopes on this distant world, the question seemed almost more important than the answer itself. Would Fomalhout B reveal its secrets, or would it remain as elusive as the stars themselves? In the search for Fomalhout B, one thing was abundantly clear. Space has a way of keeping its deepest secrets. The hunt had only just begun, and the tension between hope and uncertainty hung in the air. What do we do when we see something so close, but it vanishes before we can truly understand it? Fomalhout B was a much bigger deal than many are led to believe, and for obvious reasons. For the first time, humanity looked up, and instead of imagining, we saw. Not a sketch, not a simulation, not a shadow traced in math, but an image, a pixel of light dancing beside a star 25 light-years away, and that pixel now had a name, Fomalhout B. It may not sound like much, this faint shimmer nestled in the glow of its parent star, but in that single point of light was the culmination of centuries of curiosity, decades of work, and countless sleepless nights chasing something we weren't sure we'd ever catch. This was the first visible light image of an exoplanet, not inferred by the gravitational tug on its star, not revealed in the subtle dimming of a transit, but seen directly, like catching the flicker of a candle on the horizon after centuries of describing its smoke. To understand why this was a turning point in the story of astronomy, we need to rewind the clock. For most of human history, our skies were filled with fixed lights, pinpricks we named, charted, worshipped. The idea that those stars might have their own worlds, that our solar system wasn't unique, was a poetic dream, but not a proven one. It wasn't until 1992 that the first exoplanets were discovered, orbiting a pulsar of all things, a dead star pulsing like a metronome in the void. And in 1995 came 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. But even then, we never saw it. It was always indirect, ghosts on the charts. By the early 2000s, hundreds of these worlds had been catalogued, some hot as hellfire, others floating in eternal darkness. But none of them had a face. None had stepped into the light until now. When NASA's team released the image of Fomalhout B, it wasn't just a technical achievement. It was a moment that merged science with sensation. Seeing that pixel was like hearing a whisper across an ocean and finally spotting the figure calling your name. It had taken years to tease it out from the blinding glare of its host star. Fomalhaut is young, bright, and ringed by a stunning debris disk. That disk, astronomers believed, hinted at something sculpting it from within, something massive, hidden. So they looked. They scanned the star again and again. In 2004, they noticed a dot. In 2006, it had moved. By 2008, the movement was clear enough. This wasn't a trick of light. It was orbiting. It had a path, a rhythm. It was real, or so we thought. The announcement sent ripples through the astronomical community and well beyond. News anchors marveled. Headlines spoke of a new frontier. Teachers told wide-eyed students that they were witnessing a first. And in the language of science, firsts are rare and sacred things. It wasn't just about a new world. It was about how we saw it. This wasn't radio data or X-ray blips. This was visible light. Our light. The same kind that bounces off leaves, off skin, off the moon. Light that our eyes evolved to understand. It meant that somewhere out there, a planet could reflect starlight the way Earth reflects the sun. In technical terms, Fomalhout B seemed to orbit just inside the edge of the debris ring, possibly even shaping it with its gravity. Its brightness puzzled scientists. It was too bright for its presumed mass. Some speculated it had a large, dusty ring system of its own. Others proposed it might be surrounded by a swarm of icy fragments. It glowed, but it didn't emit the infrared heat expected from a gas giant. Still, the consensus was clear. This was a planet. A weird one, perhaps. An enigmatic one. But a planet, nonetheless. And for a while, that was enough. But Fomalhout B would not go gentle into the canon of certainty. Over the years, as better instruments took aim and sharper eyes peered deeper, questions began to bubble to the surface. Its orbit was strange, too eccentric, too sweeping. It didn't show up in thermal observations the way a planet should. Its glow began to fade, and the whispers started again. Was this a planet, or just a cloud of dust, flaring briefly like a match struck in the dark? In the years that followed, Fomalhout B slowly began to disappear, not just from images, but from belief. And yet, in some strange way, its mystery only deepened our fascination. Because even if it wasn't a planet, it was something we had seen, something that changed us. Was it a planet? A collision cloud? A cosmic illusion? Or something in between? And in a sky full of stars, how many more flickers are waiting, just out of focus, for someone to look long enough and believe? Fomalhout B was different. It shimmered. There it was, a clear, bright speck captured not once, but in multiple images from the Hubble Space Telescope. It danced just inside the icy ring of debris surrounding the star Fomalhaut. This wasn't just a dot on a chart. It was a face in the crowd. The first exoplanet ever directly imaged in visible light. But from the moment we saw it, something didn't quite add up. It was too bright. Much too bright. Like a candle glowing in the middle of a cave, brighter than it had any right to be. You see, gas giants like Fomalhout B, if that's what it was, don't emit much visible light. They're cold, especially at the vast distances where this planet resided. They might shine faintly in infrared, radiating residual heat like embers from a long dead fire. But visible light, that comes from reflection, sunlight bouncing off the planet's surface or atmosphere. So the brightness of Fomalhout B was unnatural. It didn't match what we knew, not for a planet so far from its star. It was like seeing the moon outshine the sun. Some scientists wondered, could it have a massive ring system? Maybe a cloud of dust surrounding it, scattering the light like fog in a street lamp's glow, a kind of cosmic halo. That could explain it, sort of. But even the most generous models strained to justify just how luminous it appeared. It was like trying to make a dim flashlight cast a spotlight. Something else was happening here, and the oddities didn't stop there. Fomalhout B was cold, quiet, nothing, like a ghost you can see but not feel. It didn't behave the way a planet should. Its orbit wasn't quite right. Its appearance changed over time. Its light dimmed. It shifted. It blurred. Eventually, it disappeared altogether. That's not a thing that real planets do. Planets don't vanish. But back in 2008, we didn't know any of that yet. All we knew was that we had seen something. Really seen it. A dot of light. A traveler. A possible new member of our cosmic family. It sounded like a code. A mystery. A message. And maybe it was. Because its visibility, in hindsight, wasn't proof of its planetness. It was the first crack in the illusion. Fomalhout B was starting to raise doubts, not just because of its unusually bright glow, but more. In the language of the cosmos, heat is truth. It is the whisper that lingers long after a world is born. The ember in the dark that tells us something is there, even if it hides behind clouds of dust, behind the glare of a star, or the veil of unimaginable distance. In astronomy, heat is how we see what can't be seen. Infrared light is our lantern in the void. So when scientists aimed that lantern at Fomalhout B and found nothing, that was strange. That was impossible. Let's rewind. After the initial excitement of seeing Fomalhout B in visible light, an exoplanet, finally caught in the act of existing, it was only natural to follow up with more tools, more eyes, more wavelengths. If visible light gave us a photograph, infrared could give us the warmth behind it, the substance, the signature. NASA's Spitzer Space Telescope was ideal for this kind of work. Launched in 2003, it had become one of the most trusted scouts in the dark. Where Hubble saw stars and light, Spitzer saw temperature. And planets, especially young gas giants like Fomalhout B was assumed to be, should glow in infrared like coals under a blanket. Even a cold, distant planet retains the heat of its formation. Even at 400 years after birth, Fomalhaut's age estimate, that heat should linger, quietly radiating through the dark. But Spitzer saw nothing. No warmth, no glow, no trace of infrared at all. It was as if Fomalhout B wasn't real. Or worse, it was there, but not what we thought. This absence wasn't just a curious footnote. It was a gaping hole in the story, a contradiction at the heart of the discovery. because to be bright in visible light and yet cold in infrared, that's like seeing fire that doesn't burn, like hearing thunder without lightning. It didn't make sense. Some scientists speculated that maybe the object was being hidden by a cloud of dust that scattered starlight in the visible spectrum but blocked or absorbed heat. Others thought maybe the planet had cooled much faster than expected, an outlier among outliers. But even these theories strained against the sheer nothingness Spitzer reported. No matter how imaginative the models, the simplest explanation hovered in the background like a ghost. Maybe it wasn't a planet at all. But even these theories strained against the sheer nothingness Spitzer reported. No matter how imaginative the models, the simplest explanation hovered in the background like a ghost. Maybe it wasn't a planet at all. To understand how baffling this was, consider that Spitzer had successfully detected the heat of exoplanets far more distant and much cooler. It had seen thermal signatures from so-called hot Jupiters, planets orbiting close to their stars, and even from smaller, dimmer bodies. Its silence on Fomalhout B wasn't a failure. It was a message, the kind that chills you, because what we were seeing in visible light had no internal warmth, no breath. It was like photographing a phantom. And slowly, that initial moment of celebration, the headlines, the animations, the textbooks updated with its name, began to flicker under a new light, or lack of it. The astronomy community, once confident in Fomalhout B's planetary status, began to fracture. Some held fast, citing the orbit, the brightness, the ring's disturbance. Others, increasingly vocal, pointed to the inconsistencies piling up like cosmic breadcrumbs, and eventually an object that simply wasn't there anymore. This wasn't a planet, it was a performance, a brief act across the stage of space. And the question that started to grow louder wasn't, what kind of planet is this? But what kind of trick of light are we watching? Was it the aftermath of a collision? Two icy bodies smashing together near Fomalhaut's debris ring, sending out a plume of reflective dust that momentarily caught our gaze. A slow dispersing cloud, bright in starlight but too diffuse, too thin to radiate its own heat. Or maybe even a swarm of comet-like fragments caught in motion, temporary, chaotic, spectacular. It would explain the shape, the brightness, the absence of heat, and perhaps even the disappearance. But if that were true, if Fomalhout B was never a planet, but instead the light of destruction, then what we captured on camera wasn't a world being born. It was one being undone. Astronomy is full of paradoxes. Sometimes we search for years and find nothing. Other times we find something and wish we could believe it. The lack of a heat signature broke the illusion open. It forced scientists to look harder, and it turned a planetary discovery into a mystery novel, written across light years and told in fading reflections. Fomalhaut B, once a triumph, had become a puzzle. And behind every theory, every new observation, there was the quiet, nagging question. What else are we seeing wrong? Because if the first planet we ever saw with our own eyes wasn't a planet at all, then what exactly are we looking at when we stare into the stars? When the first images were released in 2008, showing what appeared to be a planet orbiting the star Fomalhaut, the response was electric. Here was direct imaging, something astronomers had dreamed of for decades. Most exoplanets, after all, are ghosts in data, felt, not seen. They make their presence known only through subtle gravitational wobbles or the way they dim their stars as they pass in front of them. But this was different. This was visible. This was poetry wrapped in data. Hubble had plucked a planet out of the blinding glare of a nearby star. It was like spotting a firefly against a searchlight. The media exploded. "Planet caught on camera," they cried. "Astronomers photograph alien world." Animations soon followed. Simulated orbits, dramatic flybys, renderings of a massive gas giant shrouded in stormy clouds. In classrooms and planetariums, Fomalhout B became a symbol of human ingenuity, of how far we'd come since Galileo turned his lens skyward. But within the scientific community, the celebration was tinged with unease. Some were elated. For researchers like Paul Kalas, who led the discovery team, this was the culmination of years of patient work. The Hubble Space Telescope had delivered not just a result, but a moment, something that could inspire a generation. Others, however, tilted their heads. They ran the numbers, and what they saw didn't add up. How could a planet so far from its host star, some 100 astronomical units away, more than 3 times Pluto's distance from our Sun, be this bright, invisible light, yet completely invisible in heat? A gas giant should still retain warmth from its birth. It should glow in the infrared, whispering its existence in thermal tones. But Spitzer saw nothing, and that was unsettling. Conferences turned into quiet battlegrounds. Papers were published. Rebuttals followed. The planet's orbit didn't quite match expectations. It was too eccentric, too elongated. Its brightness didn't behave like that of a stable planet either. Some years it brightened, other years it dimmed. In a realm where planets are supposed to be steady, almost eternal, Fomalhout B flickered like a flame. New models emerged. Perhaps it was not a planet at all, but a vast cloud of dust, debris from a violent collision between icy bodies. Or maybe a ring system, or even a swarm of comet-like fragments reflecting light as they disintegrated. In 2012, a second team, carefully reanalyzing the data, proposed just that. They argued that what Hubble had captured was not a planet, but the aftermath of an ancient cosmic accident, a cloud masquerading as a world. Still, the debate simmered. The official databases listed it. The press kept calling it a planet. For many, the image itself was enough. But science doesn't settle for hope. It sharpens its tools. It waits. It listens. And as more data came in, the scales began to tip. Between 2004 and 2014, astronomers kept watching, and something strange happened. Fomalhout B began to fade. By 2014, it was all but gone. No slow decay, no graceful departure, just disappearance. The dot was no longer there. The firefly had vanished, and with that, the last stronghold of planetary faith began to crumble. The scientific community, now more cautious, more measured, began to reframe the story. In 2020, NASA officially downgraded Fomalhout B from its planetary status, calling it instead a dust cloud resulting from a massive collision. Paul Kalas, the man who once introduced the world to the first visible exoplanet, now stood at the front of a different revelation: that the thing they had once celebrated wasn't a planet at all. It was destruction, not creation, that Hubble had captured. And yet, many astronomers still look at that original image with awe, not because it was a mistake, but because it was a reminder of how fragile discovery is, of how easily light can lie. Fomalhout B became something more profound than a planet. It became a case study in humility. It also became a warning. In the dance between light and distance, reflection and heat, things aren't always what they seem. We may chase planets, but sometimes we catch shadows. So, what was Fomalhout B? A ghost? A mirage? A violent scar drifting through the edges of a solar system we barely understand? Perhaps the better question is not what it was, but what else is out there, shimmering on the edge of our perception. What other stars have secrets waiting to flicker, to fool us, to disappear? In science, the euphoria of discovery often wears off faster than the data can cool. Once the headlines fade and the press releases are archived, the scrutiny begins. Cold, methodical, unsentimental, and Fomalhout B didn't quite behave. Most exoplanets are stealthy, cloaked in the black velvet of their systems, detectable only by how they tug or shade their parent star. But Fomalhout B stood out in Hubble's optical range like a single drop of dew catching the sunrise. That was the first crack in the mirror. Others noticed that the object's motion didn't quite match expectations either. Planets, after all, orbit in obedience to gravitational patterns. Their movements, while grand, are predictable, like dancers tracing ellipses through space. But Fomalhout B was drifting. Not wildly, not chaotically, but strangely. Its path, when charted over multiple Hubble images, seemed too eccentric, too elongated. It wasn't circling its star like a loyal companion. It was swooping around it in a way that didn't quite fit. Was it even gravitationally bound to Fomalhaut? Was it passing through like a cosmic tourist? Even the surrounding dust ring, Fomalhaut's great icy halo, posed a problem. This ring, a vast torus of shattered rock and ice, looked sculpted, as if something massive were shaping it from within. The Discovery team believed Fomalhout B was that sculptor, a shepherd planet, corralling debris with its invisible gravitational lasso. But the position of the object didn't line up with that theory. It wasn't inside the ring's central clearing. It was skimming the edge, off-angle, like a skater gliding just outside the rink. If it was responsible for shaping the ring, it was doing so in a strangely indirect way. Some scientists proposed it wasn't shaping the ring at all, that maybe it was a leftover fragment from whatever had. Still others suggested it might not be a single planet, but a swarm, dozens or even hundreds of icy bodies grouped so tightly that from Earth's distance they blurred together into one deceptive gleam. What if it wasn't a thing, but a happening? The original team defended their claim for years, and reasonably so. Science is not quick to retract its discoveries, and Fomalhout B was, in its way, a beautiful mystery, one that demanded patience and humility. But the evidence kept drifting like stardust away from the planetary theory. A planet should endure. A planet should emit heat, follow stable orbits, and cast shadows on its system. Fomalhout B did none of that. And then, of course, it began to fade. That slow disappearance would come later. But even now, years before the Vanishing Act, the signs were there, like creaks in a grand house, whispering of a foundation that might not hold. What's more is that Fomalhout B's disappearance was just as interesting as its discovery. Diving deeper into the slow disappearance of Fomalhout B that nobody anticipated, at first it was just a flicker, a minor change in brightness, a dip barely beyond the margins of error, the kind of thing you'd chalk up to interference, an algorithm's hiccup, a speck of cosmic dust caught between us and the unknown. But this wasn't a one-off glitch. This was the beginning of an unraveling. Fomalhout B, the so-called first directly imaged exoplanet, was starting to fade, and with it, so too began the unwinding of a story that had once seemed as luminous as the object itself. Back in 2004, Fomalhout B shone in Hubble's lens like a solitary lighthouse on the edge of a celestial ocean. Bright, stubborn, and clearly visible in optical wavelengths, it was an anomaly among exoplanets. Then came the follow-ups, 2006, 2010, 2012. Each pass of the telescope brought with it a new piece of data, another thread in the story. But the thread was thinning. Careful image analysis revealed something subtle. The object's brightness wasn't stable. It was declining, slowly, quietly, but undeniably. By 2014, the decline was impossible to ignore. Fomalhout B was dimming like a dying ember, not flickering erratically, like a star affected by atmospheric noise, but steadily, like something fading from existence. In the cold logic of astrophysics, brightness is more than beauty. It's evidence. It's a clue to mass, to composition, to energy output. So when Fomalhout B began to dim, it wasn't just unsettling, it was deeply confusing. Planets don't just disappear. They don't shed brightness like old leaves in autumn. They reflect light steadily, anchored in their orbits, their visibility changing only subtly with angle and distance. Yet, here was Fomalhout B breaking the rules. What was happening? One theory caught the attention of the community, eerie in its elegance, disturbing in its implications. What if Fomalhout B had never been a planet at all? What if it had always been a cloud, and as that cloud expanded, diffused, and scattered, it would dim? It would vanish, not because it moved, but because it dispersed. Not a vanishing act then, a slow disintegration, a death by diffusion. Another possibility was even stranger. Could it be that we had witnessed the planetary equivalent of a ghost? An object passing through the system, an interstellar fragment perhaps, reflecting Fomalhaut's light like a cosmic mirror, and then moving on, slipping silently out of view. It would explain the strange orbit, the lack of heat, the fading brightness. But it raised more questions than it answered. How likely is such a transit? And why had we seen it at precisely the moment of its brief luminescence? A cosmic coincidence? Or a reminder of how thin our thread of understanding truly is? For some, the most haunting theory was also the most poetic. What if Fomalhout B was a planet, but one in its final moments? Imagine, a world torn apart, not long before we caught our first glimpse, perhaps shattered by gravitational stresses or by a cataclysmic collision with another object. Its core obliterated, its atmosphere stripped, its remnants left to scatter across space. We never saw the world itself, only its echo. The dust and ice thrown skyward in the aftermath. A planetary funeral shroud, glowing briefly in the light of its parent star before dispersing into silence. In that scenario, our first image wasn't of life, but of loss. By 2020, the verdict was becoming clear. When NASA released an updated analysis of the Hubble data, the conclusion was stunning. The object had disappeared from view entirely. Gone, not hidden, not shifted out of frame. The scientific community, once so certain they had glimpsed a distant world, was forced to reconsider. The object we had watched for over a decade had not revealed a planet, but a mirage. A brief, brilliant illusion shaped by dust and chance and time. Astronomy is often a discipline of patience, of waiting for orbits to turn, for light to arrive, for mysteries to reveal themselves over decades. And in the case of Fomalhout B, we were reminded that not all discoveries are what they seem, that the universe, even when it gives us answers, does so in riddles. We reached across the void hoping to grasp a planet, and closed our hands around starlight and dust. Nevertheless, one of the most fascinating mysteries about Fomalhout B was in its unusual orbit. When Fomalhout B was first spotted in the dusty light surrounding its parent star, it seemed to be playing by the rules. A speck of light in a still image, trailing just outside a vast, icy debris disk, a cold ring circling a bright A-type star, 25 light-years away in the constellation Pisces Austrinus. It was mysterious, yes, but still, it felt familiar, planetary, predictable. But as time passed and the speck moved, something began to feel off. Planets orbit stars in ways that obey the ancient symphony of Newton and Kepler, graceful ellipses, their tempo locked in by gravity's invisible leash. A planet moving too quickly or along too sharp a curve starts to look suspicious, like a dancer missing the beat in a performance choreographed over billions of years. Fomalhout B was out of sync. Between 2004 and 2010, astronomers tracked its motion, each image layering new data on a puzzle they thought they were close to solving. But instead of falling neatly into a planetary arc, Fomalhout B's path swerved. It wasn't simply moving around the star, it was veering away from the system's debris belt. Its trajectory didn't align with the expected orbital plane. To put it simply, the orbit made no sense. If it were a planet, it was acting like one that had been jolted, thrown, or perhaps never belonged there in the first place. By 2013, the alarm bells were growing louder. Researchers, including Paul Kalis, one of Fomalhout B's earliest champions, began to express doubts. The trajectory didn't match expectations for a stable, long-term orbit. Instead of cruising comfortably within the debris disk, like Neptune in our own solar system, Fomalhout B seemed to be cutting through it, not with the current, but across it. In celestial terms, that's a red flag. If Fomalhout B were a massive planet on such a path, its gravitational influence would have torn the disk apart. Debris would scatter. The orderly ring we see today would be a mess of jagged arcs and gaps. But the disk remained pristine, an immaculate loop of ice and dust, unbothered by any passing heavyweight. So, if the planet's path didn't disturb the ring, how could it be a planet at all? To some astronomers, the trajectory hinted at a more fleeting story. Perhaps Fomalhout B wasn't orbiting at all. Perhaps it was moving through, a transient, a cosmic passerby. One hypothesis suggested a smaller object, a collision fragment maybe, was caught momentarily in the glare, lit up by the starlight, then cast outward like a glowing ember from a campfire. Or maybe it was a planet, or had once been. A body disrupted by some long-ago cataclysm. Broken, tossed out of its native orbit, left to drift across the stellar neighborhood like a space wreck. Still others leaned towards something even more uncanny. What if the object's apparent motion wasn't even motion at all, but an illusion? An artifact of scattered light interacting with dust. A ghost of geometry, not gravity. When you look deep enough into space, even direction becomes suspect. The most haunting detail of all. Fomalhout B appeared to be headed straight out of the system. Its arc, if you extended it forward, didn't loop back to the star. It aimed outward, past the debris belt, past the outskirts of the gravitational playground. On a timeline long enough, it seemed destined to leave Fomalhaut behind entirely. Planets don't do that. Planets belong to their stars. Whatever Fomalhaut B was, it didn't. This orbital oddity cast a shadow over every assumption built in the early days. It questioned not only the nature of the object, but the very process of discovery. Had we been so eager to find a planet that we ignored the whispers of strangeness in its motion? Sometimes, the universe doesn't hand us puzzles, it hands us illusions, wrapped in just enough familiarity to fool the eye. And we, being human, fill in the blanks with what we expect to see. As astronomers mapped Fomalhout B's course through time, their models unraveled one by one. No stable planetary orbit fit the observed data. No neat solution tied the motion to mass, the brightness to body. Instead, what emerged was a portrait of contradiction. An object bright enough to see, but with no infrared signature. Massive enough to be noticed, but leaving no trace on the environment around it. Moving with intent, but in a direction that defied everything we knew about celestial mechanics. It was as if Fomalhout B was writing its own rules. Or, as some quietly began to wonder, perhaps we were chasing a shadow all along. So as Fomalhout B drifted farther from its star and from our definitions, it left behind more than questions. And one of the biggest questions was how it simply vanished. For years, Fomalhout B had danced just beyond certainty, too faint to grasp with confidence, too bright to ignore, an echo masquerading as a planet, a ghost in orbit, and then it was gone, not obscured, not hidden, gone. In the year 2020, a quiet revelation rippled through the halls of astronomy. There was no press conference, no triumphant declaration, just a paper, soft-spoken and seismic, published in Proceedings of the National Academy of Sciences. Researchers, led by Andras Gaspar and George Rieker of the University of Arizona, had returned to the archives. They combed through over a decade's worth of Hubble Space Telescope observations, layers of light and shadow painstakingly stitched together. And what they found was as startling as it was silent. Fomalhout B, the supposed exoplanet once hailed as a direct imaging triumph, had faded into nothing. Like a lighthouse swallowed by the fog, it dimmed, then flickered, then it disappeared. This was no ordinary vanishing act. Planets don't just wink out of existence. They may hide behind the glare of a star or drift temporarily behind a belt of dust, but they don't erase themselves from reality. And yet, by 2014, Fomalhout B was already losing its luster. By 2020, the ghost was untraceable in every spectrum that once caught it. Astronomers double-checked the data. They subtracted noise, filtered anomalies, rewound time. But the outcome was stubbornly clear. The object that had once brightened the edges of our maps no longer existed as anything detectable. So what had we been looking at all those years? It wasn't a planet, the researchers concluded. Not in the traditional sense. It lacked the thermal signature, no warmth, no glow. Planets, even frigid gas giants far from their stars, still radiate infrared heat. But Fomalhout B was stone cold. Its light wasn't coming from within, it was being reflected, like a mirror momentarily catching the sun before turning to shadow. The team proposed a radical new theory. Perhaps Fomalhout B was not a planet, but a cloud. Not gas, like Jupiter, but dust. Fine, drifting debris from a cataclysmic collision between two icy bodies in Fomalhaut's outer system. Imagine two ancient frozen titans, Kuiper belt cousins, smashing into one another at thousands of kilometers per hour. The result? A brilliant, spreading cloud of microscopic shards, lit for a time by the nearby star, but doomed to disperse. What we thought was a planet was the afterglow of violence, a cosmic wound still bleeding light. There's something deeply unsettling about this, isn't there? The idea that the sky can lie, that something so bright, so promising, can vanish without a trace. That we can believe in a planet for 15 years, model it, simulate it, name it, and wake up one morning to find it never truly existed. It calls into question our very methods of knowing. Astronomers are not just observers of the heavens, they are interpreters of whispers. They measure light that has traveled for decades, centuries, millennia. They build entire worlds from data points and trust that what they see is real. But Fomalhout B was a mirage, not a hoax, not an error, something stranger. A light that was, but now isn't. And here's where it gets even more uncanny. The fading itself was predicted. Back in 2012, some researchers had already begun noticing the drop in brightness. They couldn't explain it at the time, but in hindsight, it was the first indication that this was no planet. Just a cloud dispersing, like smoke caught in a beam of light, thinning with every year. By 2020, it had grown too faint to follow. The dust had moved beyond the reach of even Hubble's gaze. The story was over, but its implications were only beginning. What are we to make of this? Was Fomalhout B a one-time spectacle? A lucky glimpse of cosmic debris caught just right? Or is this more common than we think? How many of our planets are actually illusions waiting to vanish? How often does the universe let us believe a lie, simply because we lack the tools to see through it? The dust has settled. The ghost has fled, and guess what it left behind? Nothing but the mystery remains. And somewhere out there, beneath the cold gaze of Fomalhaut's white-blue light, what else might be flickering just beyond the edge of knowing? There is a moment in every mystery when the answers that seem so clear begin to unravel, like threads slipping free from the edge. Fomalhout B had once glowed in the night sky, an anomaly we were sure we understood. But then, it vanished. And not just faded into the dark. It simply ceased to exist. No debris, no rings, no lingering trace. When a planet, or a large body, disappears, we expect the universe to leave some kind of footprint, a trail of evidence, a trail of dust, a sign that something immense was once there, occupying space and time. In the case of Fomalhout B, there was nothing. No faint ring of debris left in its wake. No dramatic explosion or comet-like vaporization. No scattering of planetary matter to suggest something catastrophic had occurred. It simply wasn't there anymore. And this is where things get unsettling. Think about how we typically perceive planets. When a planet orbits its star, it leaves behind a signature, like a fingerprint that can be traced back through time. Rings, moons, orbits. These are the things that tell us a celestial body is real, is there? But Fomalhout B didn't just slip out of sight like a ship fading into a fog. There was no trail, no cometary streak in the sky, no sudden formation of rings, no debris cloud to mark its end. It was almost as if it had never been there to begin with. How could something so enormous just evaporate without a whisper? It's as though a page was torn out of a cosmic storybook and no one even remembered the chapter title. Some scientists initially theorized that Fomalhout B was surrounded by a vast cloud of icy debris. But even that theory didn't make sense, because if this had been the case, we should have seen evidence of that debris swirling, forming rings, or scattering across the orbit. But nothing ever materialized. Not a single trace. And that's the first crack in the story. Without debris, how could an object as massive as Fomalhout B have simply disappeared? A cosmic body as large as Fomalhout B, even if it was not a planet, should have left some residue, some indication of its passing, a reminder that something extraordinary had once existed in that point of space. Instead, what we got was the eerie silence of a vanished mystery. Scientists could only speculate, piecing together the most imaginative of theories. Was it a mirage? A brief cosmic anomaly that was never meant to be? Or perhaps the light and data we had been observing had been distorted by something far more complex. Maybe the object wasn't ever a planet at all, but something else. Something that appeared to behave like one, but wasn't bound by the same rules. A rogue cloud of dust, yes. But how could that dust disappear without a trace, without any scattering? Shouldn't it have taken the form of a faint ring that would linger long after the light source faded away? The universe, it seems, didn't offer those simple answers. As the years rolled by, more researchers came to the same eerie conclusion. The object that had once been hailed as a breakthrough discovery had vanished, leaving behind not the expected evidence of destruction, but nothing at all. And yet, despite this baffling silence, the absence of evidence didn't mean a thing was conclusively proven. With every new observation and every failed attempt to detect Fomalhout B, the questions piled up. Could something of this magnitude just disappear into the void without leaving a hint of its existence? Where did the material go, if not scattered or destroyed in some colossal event? Let's take a moment to think about the nature of the universe. It doesn't like to keep secrets. It is constantly churning, throwing stars into existence, scattering dust into nebulae, and pulling planets into orbits around their suns. Each of these processes is messy. Planets aren't born without leaving a trail. Stars don't burn without sending light and heat to distant corners of space. So why did Fomalhout B, this celestial body, whether a planet, a dust cloud, or something else entirely, leave behind not a shred of evidence? It's a cosmic puzzle, one that demands we reconsider everything we thought we knew about what we can observe and understand about the universe. This mystery also beckons us to think more deeply about the nature of existence itself. What is it that we define as real? In a universe so vast, so enigmatic, and so impermanent, can we ever really claim to know anything with certainty? Perhaps the ghost planet of Fomalhout B wasn't gone at all, but simply waiting to reveal a new chapter, one that lies beyond our current comprehension. The question we should be asking isn't, what happened to Fomalhout B? But rather, what does this disappearance say about the limits of our understanding? Could it be that this vanishing act is a clue to something even more profound, something just beyond our reach? Could there be other Fomalhout Bs out there, waiting in the dark corners of the universe, hiding in plain sight? Realities we can barely imagine, waiting for the day we might finally see them for what they truly are. And so, we are left with more questions, theories, and haunting thoughts about Fomalhout B. As the story of Fomalhout B unravels, it becomes harder to tell where the facts end and the theories begin. And yet, in the void left by its disappearance, a web of possible explanations has emerged, each more bewildering than the last. What we once saw as a planet, a solid, real, physical body, began to lose its shape in the minds of astronomers. It wasn't long after Fomalhout B faded from view that the first whispers of doubt began to surface. Could the disappearance be the result of a data glitch? After all, space is a vast and complex place, and the instruments we use to peer into it are not infallible. These massive telescopes, while capable of revealing the unimaginable, are still limited by the technologies that power them. A single miscalculation, a fleeting hiccup in the data. Could that be the culprit? It's not an unreasonable question. Our ability to measure light, to detect the faintest signals, is subject to the limitations of our tools. Even the mighty Hubble, with its sharp eyes turned toward the heavens, is occasionally tripped up by the vastness and the noise of space. Perhaps it wasn't Fomalhout B that disappeared, but rather the very method of seeing it. However, the notion of a glitch, while plausible, didn't satisfy everyone. For some, it was simply too tidy, too convenient. The missing planet, if that's what it truly was, seemed far too substantial, too vivid, to have slipped away with a technical fault. And so, as these doubts settled, new theories began to take root, far more intriguing and perplexing. The question of what Fomalhout B was, and still is, became the subject of fevered debate. Was it a planet? Or perhaps a piece of a planet? An artifact left behind from a cosmic collision? Some scientists began to consider the possibility that what we were observing was not a single object at all, but a strange intersection of multiple phenomena. A dust cloud, perhaps, in combination with the remnants of shattered material from an earlier collision. An eerie, transient dance that only briefly coalesced into something we could recognize as a planet. And then there were those who wondered if Fomalhout B was simply in the wrong place at the wrong time. Could it have been a background object, something on the far, far edge of our perception, lingering just behind a veil of distant stars, its brief appearance just a trick of perspective? A celestial mirage that danced in front of our eyes, only to disappear as swiftly as it had arrived. But even these theories, fascinating as they were, failed to fully explain the strange disappearance. Why, after all, would such a structure, whether dust cloud, planetary body, or optical illusion, leave no trace of itself? No lingering fragments, no faint glow in the darkness to mark its passing. The more the theories multiplied, the more the mystery deepened. Every new explanation only seemed to create more questions, pulling us further from a solid understanding of what Fomalhout B was, or had been. As the scientific community pieced together its hypotheses, there was something even more unnerving lurking in the background, the possibility that our search for answers might be fundamentally flawed. After all, we are limited by the very tools we use to understand the universe. We can only see what our instruments allow us to see, and we can only comprehend what our minds are equipped to grasp. What if the true nature of Fomalhout B lay beyond those limits, beyond the reach of human understanding? Perhaps the greatest enigma of all is this. In our quest to understand, we may have been looking at the wrong thing all along. Perhaps the disappearance of Fomalhout B is not just a cosmic riddle, but a reflection of our own limitations. What if the answers we seek lie in a higher dimension that we are not yet able to reach? The more we search, the more we realize how much we still don't know about the universe, about what's real and what's illusion, about what we can see and what might be waiting just beyond the horizon, hidden in the dark. As the theories pile up, we are left with a quiet question, hanging in the air like a star slowly fading from view. Was Fomalhout B ever really there at all, or did it simply slip through the cracks of our understanding, like a ghost that never truly existed? Make no mistake, every single one of these theories is mind-boggling in its own right. Of course, all of them come with their own set of shortcomings as well that can only be seen with a closer look. In space, collisions are not just possibilities, they are certainties. Stars merge, black holes devour, and comets crash, sending debris scattering like celestial confetti. Once the existence of Fomalhout B came under scrutiny, dozens of theories emerged to try and explain its strange behavior. Among those theories was one that asked, what if it was not a new planet, but instead the remains of something much older, something that had already been torn apart? This idea, the theory of a planetary collision, begins to unfold as a powerful explanation for what Fomalhout B really was. Perhaps, instead of being a planet in the making, the object was nothing more than a cloud of debris, a massive, shattering result of two icy bodies colliding at the edges of space. But how can we understand the magnitude of such an event? Imagine two icy giants, planetesimals, remnants of the primordial dust that once filled the early solar system, hurling toward each other, driven by gravity and fate. Then, in a cosmic instant, they collide. The impact is monumental. Matter is pulverized, compressed, scattered like the fragments of a shattered mirror, and in this violent release of energy, a new form of chaos is born. Not a planet, but a cloud of dust and gas, glowing faintly in the cold darkness, held together by the very gravity that broke it apart. This would explain why Fomalhout B never quite fit the picture of a traditional planet. It had no solid surface, no distinct atmosphere, only the flickering remains of a collision drifting in orbit around its parent star. This theory pulls us into the kind of profound, almost tragic beauty that comes with the end of one thing and the birth of another. The destruction of a planet, if indeed that's what happened here, doesn't create a void. Instead, it creates a fleeting moment of brilliance. For a brief time, the remains of this collision burned brightly enough to catch the eyes of astronomers, a distant yet haunting flash of light in the vast emptiness of space. But like all things in the universe, it didn't last. Over time, the dust began to dissipate, fading from view as the remains of the collision scattered farther and farther, eventually becoming invisible to our instruments. The ghost of a planet, once thought to be real, slowly became just a memory. As we think about this theory, it's impossible not to feel the emotional weight of what such a collision must have been like. In a way, it mirrors the transience of life itself, the fleeting, fragile nature of existence. Fomalhout B was once a dazzling promise, a signal in the dark, but its brief existence was marked by destruction. Yet that destruction wasn't without purpose. The remnants of this collision, a collection of icy debris and dust, have given us a glimpse into the processes that shape the formation of planetary systems, a reminder that even in chaos, there is beauty and order. The dust may have scattered, but in doing so, it offered us a unique opportunity to observe the cosmic forces at play in the universe's grand tapestry. Think about the implications of this theory for a moment. If Fomalhout B was indeed the result of a collision, then it stands as a reminder that the universe is a dynamic, ever-changing place. Nothing is static, not even the planets we think we know. The objects we've long considered to be fixed points in space, our planets, our stars, are, in reality, caught in a ceaseless dance of creation and destruction. The collision that birthed Fomalhout B could have been a violent, cataclysmic event, but it was also part of the natural cycle of life in the universe. It was a brief moment, one of infinite others, where something new came into being from the ashes of something old. And then there's the question of what became of all that debris. After the initial explosion, after the dust began to settle, did any of it come together again? Did the fragments form new worlds, new moons, or even new stars? Or did they simply fade away, lost in the cosmic winds, never to be seen again? Some might argue that the debris of Fomalhout B holds the key to understanding how planets form. Others may wonder if the scattering of these icy bodies is a signal that we, as humans, are always on the verge of finding something before it vanishes. In the end, the real question may not be whether Fomalhout B ever existed as a planet, but whether we are truly capable of understanding the fleeting, chaotic moments that make up the universe. And in the search for that understanding, will we ever be able to hold on to the things we discover, or will they always slip through our fingers like stardust? Is the universe, like Fomalhout B, just a brief, fleeting moment of dust, forever caught between creation and destruction? Or is there more to discover in the spaces where nothing remains but the echoes of the past? The collision theory is more than just a scientific explanation, and to truly appreciate it, one must look at how collisions work in space. Collisions in deep space are not like car crashes on Earth. There are no screeching tires, no shattering glass, only the crushing, silent devastation of cosmic bodies colliding at unimaginable speeds. And yet, despite the silence, these cosmic events can ripple through the very fabric of space-time. They create stars, forge planets, and send debris scattering across vast distances. Some of the most brilliant and catastrophic moments in the universe arise from these celestial crashes, and sometimes what we thought were solid, stable worlds can disappear in a blink of an eye, much like Fomalhout B. Let's slow down for a moment and consider just how fast these collisions occur. When two celestial bodies, be they asteroids, comets, or even nascent planets, collide, they do so at speeds that are hard to fathom. These objects can be traveling at tens of kilometers per second, and when they meet, the impact is not a gentle nudge, but a violent release of energy. Imagine two trains barreling toward each other, but instead of metal and flesh, it's ice, rock, and gas crashing together. At these speeds, the energy released is staggering. A collision between two icy bodies could send debris flying in all directions, creating a cloud of dust and vaporized material that glows faintly as it moves away from the point of impact. Yet, even in the aftermath, the remnants of this impact may not behave as you might expect. Unlike our earthly collisions, where debris often settles into familiar patterns, space collisions leave behind clouds, ghostly and fleeting. These clouds are not static, but ever-changing, drifting, dissipating, and often vanishing from our sight. As is the case with Fomalhout B, the objects that remain from these collisions can form complex structures, glowing rings, belts of debris, or swirling clouds of gas, but the most surprising part of it all is how ephemeral they can be. So, how do we spot these cosmic collisions? How do we catch a glimpse of the chaos hidden in the void of space? Well, astronomers don't have the luxury of watching the impact unfold in real time, but they do have sophisticated instruments that allow them to see the aftermath. Telescopes like the Hubble Space Telescope and the recently upgraded James Webb Space Telescope peer deep into the universe, capturing light from distant stars and the remnants of their surrounding debris. These observations allow us to detect the faint signatures of collisions, usually through the glowing remnants of dust or the formation of rings that result from the debris left in a planet's wake. However, the complexity of these collisions makes them difficult to spot. Often the debris is not bright enough, or it fades too quickly, slipping away into the vastness of space before we can study it in detail. The light emitted from these events is fleeting, caught in the brief window of time when the collision is still releasing energy. Much like Fomalhout B, which flickered like a candle in the cosmic dark before vanishing, the remnants of such collisions often disappear, leaving little trace behind. The light emitted by the collision can be seen in certain wavelengths, infrared or ultraviolet, but in the long run, these signals fade, and the universe goes on as if nothing ever happened. The fascinating part of this process, though, is that these events are not always complete endings. The destruction caused by a collision may leave behind something new. This new thing could be a star, its birth ignited by the violent release of energy, or it could be a planet forming out of the chaos as particles of dust and debris coalesce into a new world. Sometimes it's neither. Sometimes it's just an ethereal cloud of gas and dust that spins away, carrying with it the memory of the violence that caused it. Take, for example, the famous example of the asteroid belt in our own solar system. It's a remnant of a collision, a vast expanse of rocky debris that never formed into a planet due to the gravitational interference of Jupiter. But even in the case of planetary collisions, we're left with this profound beauty in the aftermath, a scattering of particles that tell the story of a once whole world torn apart. Sometimes, this debris forms rings around a planet, like the rings of Saturn. Other times, it just disperses into space, becoming invisible to our instruments as it fades away, just like Fomalhaut B. So, when we look at Fomalhaut B and consider it in the context of these cosmic collisions, we must remember that space itself has a way of hiding the scars of these impacts. What we see as a planet may, in fact, be a fleeting ghost, a cloud of debris that once was. What was once thought to be a stable object might just have been the violent end of something else, a brilliant flash of destruction that slowly faded from view. This makes the question of what Fomalhaut B truly was even more haunting. It's not just the mystery of whether it was a planet or a cloud of dust that haunts us, but the mystery of how fragile even the most colossal things in the universe truly are. If the universe is built on collisions, on moments of destruction and creation, what does that say about the nature of existence itself? Are we just all floating in space, waiting for our own collision to define us, only to vanish like a ghost into the infinite dark? In the case of Fomalhaut B, there were a bunch of different simulations to try and explain its disappearance. However, one might argue that it only ended up complicating things further. Fomalhaut B flickered in and out of existence like a star on the verge of dying. We thought we had it figured out, that it was a planet, a new world spinning in the distant corners of the cosmos. But as the light began to fade, so too did the certainty. Then came the simulations. At first, the mystery of Fomalhaut B's sudden disappearance left astronomers scrambling, trying to reconcile their observations with the data they had. The planet, if that's what it truly was behaving unlike any other celestial body we had seen. Its signature, once bright and visible, began to fade, almost as if it were dissipating into the very fabric of space. And it wasn't just the fading light that puzzled scientists. The object's orbital behavior, the way it moved, didn't quite match expectations. It didn't fit into the neat boxes of planetary models, nor did it conform to what we had come to expect from a stable, distant world. That's when the power of computer simulations was brought into the equation. Imagine, if you will, a model, a virtual map of the stars, a landscape of data points, calculations and equations running in harmony. These models didn't simply look at the stars as they are today, but as they were in the past and how they might be in the future. The simulations, designed to recreate the physics of planetary systems, were set to work on Fomalhaut B's fading mystery. The astronomers behind these models weren't looking for a planet at all, they were looking for an explanation. What the simulations revealed was something far more intriguing. They ended up supporting the idea that Fomalhaut B wasn't a planet at all, but rather the debris from a cosmic collision. The objects in the simulation, two icy bodies colliding at incredible speeds, were perfectly aligned with what we observed from Fomalhaut B's behavior. Now, this wasn't just some casual experiment. These simulations were grounded in the fundamental physics of space, the laws of motion, gravity, and thermodynamics. They recreated the conditions of an enormous crash between two icy bodies, a scenario that seemed, at first glance, almost too catastrophic to believe. Yet, as the models played out, they matched the data with chilling precision. They showed that the debris from such a collision would form a cloud of dust, a cloud that could grow dense enough to appear briefly as a visible object, but not stable enough to last. The faint, flickering light from Fomalhaut B, which had once been seen as the glowing signature of a new planet, now revealed itself to be the dissipating remnants of this cosmic disaster. The dust and gas swirling through space were not bound together as a planet, but scattered in all directions, slowly fading as it drifted further from the point of impact. It was as if we had been watching the final moments of something's life, the death rattle of a celestial body. The data didn't lie. Fomalhout B wasn't a planet at all. It was the ghost of a planet, the shattered pieces of what might have once been a world, now scattered like stardust in the void. This discovery wasn't just a blow to our understanding of Fomalhout B. It was a blow to the way we perceive the universe itself. We had been looking for something solid, something tangible, but the universe had shown us that even the most certain things can be illusions. The simulations didn't just reveal the fate of Fomalhout B. They revealed the delicate balance between destruction and creation that governs the cosmos. What was once thought to be a stable, bright planet was revealed to be a brief flash of beauty born from catastrophe. The object we saw wasn't a planet waiting to be explored. It was a moment, a fleeting memory of what once was. Fomalhout B, in its brief existence, captured the imagination of so many. We had hoped it was a new world, a discovery that could tell us more about the secrets of the stars. But instead, it left us with a deeper question. How much of what we see is real, and how much of it is just dust and illusion? The mystery behind Fomalhout B becomes more and more obvious once we piece together the timeline of its existence. The tale of Fomalhout B is a story that began with a violent collision, reached its end in a brief moment of radiance, and then faded into nothingness, leaving only the whispers of its existence. But the true story of Fomalhout B isn't simply a mystery of disappearance. To understand what happened to Fomalhout B, we must first imagine the scene. Two icy bodies spiraling toward each other at unimaginable speeds. The collision, when it finally occurred, was not a slow, graceful impact, but rather an explosion of force and energy, far more violent than anything we can experience on Earth. These objects, remnants of a nascent planet, crashed into one another, their icy shells shattered, their ancient materials scattered. The debris formed a vast, swirling cloud of dust and gas, a cloud so dense that for a time it glowed brightly against the blackness of space. The timeline of Fomalhout B's brief existence can be traced like the arc of a falling star. At first, the collision created little more than chaos, an explosion of matter, a burst of energy so powerful that the debris from the collision began to radiate light. This moment, when the dust cloud began to shine, marked the birth of what we would later come to call Fomalhout B. But this light, this glow, was not the light of a new planet being born. No, this was a transient flash. The debris cloud, in the heat of its formation, glowed brighter than any planet could. The material, mostly dust particles, gas, and ice, was flung outward at incredible speeds, the result of an impact so massive that it set the pieces of the former world into motion, scattering them across the vast emptiness of space. For a time, Fomalhout B shone like a star, a brief flash of light that lingered in the distance, caught in the gravitational embrace of the Fomalhaut system. It was like a comet, its brightness waxing and waning, its form never truly solid, never truly stable. But like all things that burn too brightly, this cloud would eventually lose its light. The dust, as it drifted outward, cooled. The gas began to dissipate. The very particles that once formed a glowing nebula of potential would begin to fade, scattering and becoming less and less visible with each passing moment. The peak of brightness, the moment when Fomalhout B's light was at its most intense, was fleeting. It was not a slow crescendo or a steady burn, but a brilliant flash that illuminated the heavens before it was gone. In this brief window, astronomers caught sight of the object, hoping to uncover the secrets of what they believed to be a planet. They marveled at the clarity of its light, its unusual form, and the strange way it appeared to drift, as if it were a silent wanderer in the galaxy. But just as quickly as it had appeared, the light began to fade. The dust cloud that had once glowed with such intensity slowly began to disperse, its remnants stretching further into the void. As the gas and dust spread out, the cloud became less and less detectable. What was once a shining, bright object became a shadow, a ghost of its former self, leaving astronomers to wonder, had it ever been there at all? The fading of Fomalhout B was not a singular event, but a gradual process. As the cloud expanded, it cooled, losing the energy it had absorbed from the collision. The light that had once illuminated the heavens faded into obscurity, leaving only a faint trace of its existence. The cloud's density diminished, and with it, its visibility. The brilliant signature that had once been a beacon in the sky became a faint whisper, a memory slowly vanishing into the depths of space. Now, as we look back on this event, it's important to remember that Fomalhout B was never truly a planet. It was never a solid, stable world orbiting a distant star. Instead, it was the aftermath of a violent event, a brief, beautiful moment in the cosmos created by the collision of two icy bodies. The timeline of this event, from the violent collision to the rapid expansion of the dust cloud and its eventual fading, is a testament to the ephemeral nature of life in the universe. In the vast, cold expanse of space, nothing is permanent. Even the most brilliant flashes of light are fleeting, disappearing as quickly as they appear. The idea that Fomalhout B was ever a planet might have been a mistake, but it wasn't without good reason. In fact, in the early stages of its discovery, we had every reason to believe that it was a planet. For years, Fomalhout B stood as one of the brightest stars in the firmament of astronomical mysteries. To the trained eye, its existence seemed undeniable. But how could it have fooled even the most seasoned astronomers? What was it about this strange and elusive object that made it appear for all the world like a planet? It all begins with timing, perfect timing, and the delicate dance of light and shadow. When Fomalhout B first caught the attention of the astronomical community, the star Fomalhaut, already known for its circumstellar disk of dust and gas, became the focal point of a new, exciting discovery. A planet, or so it seemed, was orbiting this star, its presence first hinted at by the glow of a distant world, a faint speck caught in the light. This was no ordinary discovery. In the field of exoplanet hunting, spotting a new world in the vastness of space is rare enough. But Fomalhout B seemed special. It appeared to be perfectly positioned, almost too perfectly. Positioned just right, its orbit seemed to match the conditions one would expect of a planet, moving in a steady path around its star. The timing of the observation, made just as the dust cloud around Fomalhaut was interacting with the light, was almost as if the universe had set the stage for a grand reveal. But the real trick, the sleight of hand that made Fomalhout B appear to be a planet, was the viewing angle. Imagine a moment frozen in time. You're standing in a vast, silent room, and the way the light hits an object gives it the illusion of depth, of substance. In this case, the angle of the observation made it look like something that fit our expectations of a planet. It was the right size, the right distance from its star, and it was casting just the right amount of light, a bright, shiny beacon in the otherwise dark space. This is where things get tricky. What astronomers were actually observing wasn't a solid, stable planet. Instead, it was the debris of a cosmic catastrophe, a cloud of dust and gas, expanding outward, glowing in the light from Fomalhaut. This cloud, the product of a violent collision, had formed into a shape that mimicked the characteristics of a planet, an object moving in orbit, a bright, solid-looking disk. In essence, it was an illusion, a temporary illusion, one created by the light scattering off the dust particles. The viewing angle, so perfectly timed, made it appear as if Fomalhout B was a planet in orbit, and the amount of light reflected off the particles led astronomers to believe they were witnessing the birth of a new world. But the truth was far less straightforward. The dust cloud wasn't a planet at all, but the aftermath of destruction, a temporary burst of brightness caused by the scattering of light. The debris moved outward, expanding into space, but as it did, it became more diffuse, less visible, and less defined. For astronomers, the discovery was exciting. The data, the images, they all pointed to a planet. The size and shape of the object, its luminosity, its apparent position in the Fomalhaut system, and the way it seemed to interact with the surrounding dust all led to the same conclusion. A planet had been found. It seemed like the final piece of a puzzle that had eluded us for so long. But nature, in her infinite complexity, had other plans. As the dust cloud expanded, it began to dissipate. The very thing that made Fomalhout B seem like a planet, the way it caught and reflected light, began to fade. The illusion began to crumble. What was once a brilliant, shiny object grew fainter, more elusive. The planet that everyone had thought they'd found wasn't a planet at all. It was simply a ghost, a fleeting moment in the life of the cosmos. So how did it all happen? Why were we so easily tricked into seeing what wasn't there? The truth lies in the inherent nature of observation, in the vastness of space, where distances are measured in light years and time stretches across eons. It's easy for us to mistake a fleeting flash of light for something far more enduring. The laws of physics, the same ones that govern planets and stars, also govern dust clouds and debris. Yet we, as human beings, have a tendency to cling to what we want to see, to what fits our expectations. The idea of a planet, solid and real, is so alluring, so tangible, that it's hard not to believe it when the evidence, in the form of light and shape, seems to line up perfectly. But the universe doesn't always play by the rules we've set for it. Sometimes it offers us illusions, things that seem real but fade away just as quickly as they appear. Fomalhout B was one such illusion, a momentary flash in the cosmic darkness, beautiful and bright, but ultimately fleeting. As the years passed, astronomers revisited their observations, re-examined the data, and began to notice something strange. The object wasn't behaving like a planet should. It didn't have the mass or gravitational influence of a planet. It wasn't in a stable orbit. It wasn't even the right shape. What had once been a dazzling discovery began to unravel, revealing a truth far more complex than anyone had expected. The revelation that Fomalhout B wasn't a planet came as a disappointment for a lot of people. However, when the initial shock passed, people found a new appreciation for Fomalhout B. Imagine a planet, one that has existed for eons, spinning in a steady rhythm around its star, carrying with it all the potential for life, for history, for discovery. Now imagine this planet, in a sudden and catastrophic instant, meeting its end. Not in some distant mythic future, but right before our eyes. We had witnessed the death of a planet. That's the possibility that haunted the astronomers who first caught sight of Fomalhout B, the ghost planet that would fade into oblivion. Could it have been a world, one that had once thrived, meeting a tragic end in a violent collision? Was this the rare, destructive fate of a planet, a once thriving sphere turned to dust by cosmic forces too powerful to resist? The idea of a planet being destroyed isn't one we usually entertain. Planets, in the grand theater of the cosmos, seem like eternal players, stable, predictable, enduring. They orbit their stars for billions of years, keeping to their paths, unaffected by the chaos that rages around them. It's easy to think of planets as permanent fixtures in the sky, their existence safe in the hands of gravity, the cosmos's unyielding rulebook. But the more we explore, the more we realize just how fragile that permanence truly is. When Fomalhout B appeared on our radar, it seemed like the perfect candidate for something that could shake that assumption. A fleeting flicker in the vastness of space, a perfect storm of timing and viewing angle made it look like a planet, until it didn't. But what if, beneath that illusion, there had been a truth far more haunting? What if this was a planet we had just caught being destroyed? We know that collisions happen all the time in the universe. It's a brutal dance in which comets, asteroids, and other celestial bodies crash together, often with catastrophic consequences. But the destruction of an actual planet, a world with its own gravitational pull, its own atmosphere, its own tectonic activity, that's a rare and extraordinary event. It's the kind of event that shakes the very foundations of a solar system, the kind of thing that leaves a mark on the cosmos. In the case of Fomalhout B, the sudden burst of light we were observing had been the result of such a catastrophic event. A planet on the verge of destruction, sending out a final flare as it collided with another celestial body, an object so massive that the force of the impact shattered it. Perhaps what we were seeing was a temporary bright spot, a last gasp of a dying world as it was torn apart by the cosmic chaos of an unforgiving universe. The idea of planetary destruction isn't as far-fetched as it might sound. Astronomers have long suspected that the early solar system, our solar system, was a violent, chaotic place. Planets collided, moons shattered, and debris was scattered across the heavens. The Earth itself likely owes its existence to such collisions. But what's rare, what's extraordinary, is the idea that we could witness such an event in real time, watching as a planet's final moments unfold in a burst of light and energy. And yet, the more we look at it, the more complicated the question becomes. Could it really have been a planet? To answer that, we must first understand the peculiar nature of the event itself. The brightness of Fomalhout B's appearance suggested something more than just a simple planetary reflection of light. It was too dramatic, too sudden, too intense. If this were indeed the destruction of a planet, it would have to be a rare, unique event, a collision of forces so extreme that it outshone the planet's normal reflective glow. The debris from such an event would have been scattered, causing the light to shift, to shimmer, to fade. But the idea that we caught this planet in its death throes is still hard to grasp. After all, the lifespan of a planet, especially one like Fomalhout B, should be measured in billions of years. Even in the most violent of systems, planetary destruction happens on such a slow scale, so gradually that it's often invisible to us. The idea that we might have caught it right at the apex of its destruction, a brief, brilliant flare, visible from light years away, seems like something out of a science fiction novel. Still, the possibility lingers, like an echo in the darkness of space. Could this rare event have been the source of the strange, sudden fading of Fomalhout B? Could this planet have been shattered in some cosmic collision, leaving behind only the telltale signature of its death, scattered like dust across the cosmos? The thought of witnessing such a spectacle, of seeing a planet fall apart before our very eyes, stirs something deeply primal within us. Perhaps it is the realization of how small we truly are in the grand span of the universe, how even the most enduring, seemingly unbreakable objects are vulnerable to the forces of time and chaos. Or perhaps it's the recognition that the universe itself is a stage of constant change, where even the most ordinary events, like the sudden fading of a planet, are actually extraordinary moments in a much larger, unknowable drama. We may never know the full truth of what happened to Fomalhout B. The mystery remains, a question that drifts, like stardust, through the vast expanse of time. Was it the death of a planet, or was it just another illusion in the theater of space? And as we ponder that question, we're left with one lingering thought. How often do we truly witness something so fleeting, so rare, and so utterly beautiful that we can hardly believe it happened at all? Fomalhout B's existence is a rare glimpse into what more secrets this universe has yet to offer. We live in a universe full of mysteries, some grand and eternal, others fleeting and ephemeral. When we look up at the stars, we often feel like we're peering into the vast unknown, seeing the faint flicker of distant worlds, unaware of what secrets might be hidden within their light. But every now and then, something happens that breaks through the ordinary, something that makes us ask, what are we really seeing up there? Such was the case with Fomalhout B, a planet that seemed to appear out of nowhere, only to vanish in an equally mysterious fashion. A bright burst of light, an image frozen in time, as if the planet itself had flickered into existence for the briefest moment before being swallowed by the black void. But was it a once-in-a-lifetime event, a rare cosmic phenomenon? Or perhaps is this just one instance in a much larger, unnoticed pattern of planetary mysteries that we're simply too far removed to see? The idea of catching a glimpse of something like Fomalhout B is enough to stir the imagination. What if we were looking at a truly rare occurrence, something that only happens once every few billion years? The timing of our observation, the perfect alignment of the stars, the position of the planet, and our exact angle of vision, all of it combine to allow us to witness something almost too incredible to believe. It's a cosmic accident, a perfect storm of circumstances that might never be repeated. Or so we thought. But perhaps this event is not as rare as we believe. Perhaps it's just that we're not looking closely enough, not seeing the forest for the trees. For all the stunning discoveries we've made in the cosmos, the truth is that much of the universe remains hidden from us, veiled in mystery. Our telescopes, as advanced as they are, only allow us to peer at a fraction of the heavens. We see only what's close enough, bright enough, or distinct enough to make an impression on our instruments. The rest, the vast majority of the cosmic landscape, remains outside our grasp. It's easy to assume that such events are rare because we've only just begun to look at the stars in earnest. The technology we now have, advanced telescopes, precise imaging techniques, and powerful simulations, has opened a window into the heavens that was once sealed shut. But what if, for all our innovations, we're still missing most of the picture? How many Fomalhout Bs are out there, hiding in the shadows, waiting for the right moment to reveal themselves? And how many more will slip quietly into the void, unnoticed, forever? Perhaps we're seeing only the tip of an iceberg. The signs that would have gone unnoticed before, subtle glimmers of planetary destruction, brief moments of illumination, the faintest shifts in light and shadow, are now caught in the vast web of our telescopes and sensors. What once would have passed unnoticed is now catalogued, recorded, analyzed. But the question remains, how many cosmic coincidences have we missed simply because we weren't in the right place at the right time, or we lacked the knowledge to know what we were seeing? There's a certain humbling beauty in this thought. The universe, with all its endless stars and planets, is full of stories. Stories we may never hear, stories that pass us by like whispers in the night. Each of these fleeting events, like the rise and fall of Fomalhout B, speaks to the delicate balance of forces that govern the cosmos and the fragility of life, even in the vastness of space. Could this rare glimpse into the life cycle of a planet be just the beginning of a deeper story we're only now beginning to understand? If we accept that cosmic coincidences happen and that events like the vanishing of Fomalhout B may not be as rare as they seem, it opens up an intriguing thought. How much of the universe's hidden wonders are we still missing? Perhaps the true scale of what's happening in the far reaches of space is far greater than we can comprehend, and we've only just started scratching the surface. What if, in another decade or another century, we look back on Fomalhout B and realize that we were seeing only a fraction of a far larger, more intricate pattern? Could this be a sign of things to come, a preview of the deeper mysteries waiting to be uncovered? Or was Fomalhout B simply a cosmic accident, a one-in-a-lifetime event that will forever remain unique in its mystery? And if we've learned anything, it's that the universe, in its infinite complexity, holds more secrets than we'll ever truly understand. The question remains, what else is out there, waiting to be discovered, hidden just out of sight, its story only waiting for the right observer to catch a glimpse? Perhaps the real mystery isn't in what we see, but in what we fail to see. Fomalhout B alone has taught us more about our universe than any other planetary discovery in recent years. This includes both existential lessons and more technical ones, especially the need to improve our exoplanet detection methods so that we don't make the same mistake twice that sent us on this wild goose chase for a planet that never existed. When we think of planets, we often picture something stable, grounded. We imagine distant orbits, vast stretches of space with predictable patterns, much like the planets in our own solar system. But this is not how the universe works, especially when we turn our gaze to the far reaches of space, where the stars twinkle like distant embers and planets hide beneath the cosmic shroud. Finding a planet light years away, one that is orbiting a star far beyond our reach, is no simple task. It's like trying to spot a single grain of sand on a vast beach under a midnight sky. The sheer distance alone, millions, even billions of miles, creates a challenge so enormous that the task often feels as elusive as capturing a breath of wind in the palm of your hand. The methods we use to detect exoplanets, those planets beyond our own solar system, are intricate and delicate. One popular technique involves measuring the dimming of a star's light as a planet passes in front of it, a method known as the transit method. Imagine it as a tiny shadow casting over the surface of a distant, glowing orb. But even this seemingly straightforward approach comes with its own set of complications. The shadow of a planet is incredibly faint, and the odds of being in exactly the right spot at precisely the right time are astronomically small. A small misstep, a slight error, and the planet remains hidden, invisible to our instruments. Other methods, like the radial velocity method, measure the subtle wobble of a star caused by the gravitational pull of an orbiting planet. Even this technique requires us to make incredibly fine measurements of a star's movement to detect a shift so slight that it's measured in mere fractions of a second. Like trying to measure the minute twitch of a dancer's foot, it demands extraordinary precision. But these methods, while revolutionary, are not foolproof. The universe is vast, and the instruments we use are only small windows into its complexities. Our gaze is narrow, focused on tiny slices of time and space, and even a brief passing moment of activity can be enough to slip through our observational grasp. And so, mistakes are bound to happen. Take Fomalhout B, for example. When it was first spotted, it seemed like the perfect discovery. Here was a planet, bright, clear, and unmistakable, located in the relatively nearby Fomalhaut system, some 25 light-years away. Its signature was striking. It was unlike anything we had seen before, a shimmering beacon among the stars. A beacon so bright, in fact, that we couldn't help but think we were staring at a planet in its prime, ripe for study, ready to reveal all its secrets. But what if the planet we saw was never truly there in the way we imagined? What if, instead of a planet, we were looking at something else entirely? An illusion created by dust, a fleeting cosmic event caught at just the right angle. Perhaps this wasn't a planet at all, but rather a cloud of debris, a remnant of something that had once been. That's the tricky part about exoplanet detection. We often see what we want to see, what fits the models we've built, what aligns with our expectations. Our gaze is clouded, much like a dream that slips away upon waking. It's only in hindsight, after a closer inspection, that we realize the truth is more complicated than we could have ever imagined. What made Fomalhout B stand out wasn't just its bright signature or its placement. It was the timing, the way everything lined up just so, creating the perfect illusion of a planet in the act of forming or dying, or maybe both. But this perfect alignment is exactly what makes these discoveries so difficult to pin down. The universe doesn't play by our rules, and the signals we pick up are often far more complex than our instruments can interpret. A mistake is not just possible, it's inevitable. This is where the wonder of exoplanet detection lies, not just in the discovery of new worlds, but in the beauty of the questions we have to ask. Every time we detect a new planet, we're not just looking at a distant world. We're peering into the heart of uncertainty, wondering whether we've truly grasped the truth or if we've only glimpsed its shadow. The more we learn, the more we realize how much we don't know. Each discovery, each failed detection teaches us something new about the limitations of our understanding. The universe is full of ghosts, of things that slip through the cracks of our comprehension, and Fomalhout B was one of them. But why does this matter? Why do we keep looking? Why do we keep reaching for the stars, even when the answers we seek seem just out of our grasp? The answer is simple and yet profoundly complicated: curiosity. The desire to know, to understand, to uncover the mysteries of existence. Fomalhout B may have vanished, but in doing so, it taught us something incredibly valuable. The search for planets and for answers is never easy. It requires patience, humility, and an acceptance of the unknown. But in the end, it's not just the discoveries that matter. It's the questions they spark, the new paths they reveal. After all, if we knew everything already, would there even be a reason to look? When we search the heavens for new planets, the universe doesn't make it easy. It's like trying to read a book written in a language we can barely understand, with only a few scattered pages as clues. Astronomers have been trying to piece together this celestial puzzle for centuries, and over time, we've developed a handful of methods to help us spot distant worlds. Each one like a different tool in a toolkit, each with its own strengths and limitations. There are three primary ways we find planets: direct imaging, transit detection, and radial velocity, and each of them offers us a different glimpse into the vastness of space. Imagine standing in a dark room, trying to find an object that is hidden from sight. Each of these methods is like shining a different kind of light into the room. Some give us clearer views, some only show us shadows, but all are imperfect, incomplete. Let's begin with direct imaging. This is perhaps the most intuitive. It's exactly what it sounds like, pointing our instruments toward a star and trying to capture an image of a planet orbiting around it. It's like using a magnifying glass to try to spot a tiny insect moving against the backdrop of a bright sky. The challenge with direct imaging, though, is that the stars we're looking at are incredibly bright, and they can easily drown out the faint light coming from a planet. Imagine standing on a sunny beach, trying to spot a small pebble under a shadowed rock. It's hard, nearly impossible. To make it work, astronomers need to use advanced techniques to block out the star's overwhelming light, leaving just enough room to capture the faint glow of the planet. This method is only successful with giant planets that are far away from their stars. Planets like Fomalhout B, which was discovered in this way, shining brightly enough to stand out against the star's light. Then there's the transit method, which is a bit like waiting for a plane to fly in front of the sun and briefly dim the light. In this case, astronomers wait for a planet to pass directly between us and its host star. As the planet moves in front of the star, it causes a small dip in the star's brightness, a signal that we can detect. It's a subtle effect, like watching the shadow of a butterfly cross the face of the moon, but it's a reliable one. This is how the Kepler Space Telescope, launched in 2009, found thousands of exoplanets. The transit method is incredibly effective because it gives us a precise, repeatable signal that tells us the size of the planet and its orbit. However, it has its own limitations. For one, we can only observe planets that happen to cross in front of their stars from our vantage point on Earth. If the planet's orbit is tilted just a little bit differently, we'll never see it. It's like waiting for the perfect moment to catch a glimpse of a distant ship sailing past a lighthouse. But if the ship sails just out of view, we miss it entirely. The third major technique is radial velocity, or the Doppler method. This one is a little harder to grasp, but it's one of the most powerful. Imagine standing on the edge of a train platform as a train approaches you. As it gets closer, the sound of the train's whistle changes pitch, getting higher. This shift in sound is a result of the Doppler effect, where waves, whether light or sound, change in frequency as an object moves toward or away from you. In space, stars do something similar. When a planet orbits its star, it exerts a slight gravitational tug, causing the star to wobble a little. The Doppler method measures this wobble, detecting the shift in the star's light as it moves toward or away from us. This is how we discover smaller, more distant planets that might not be bright enough for direct imaging or in the perfect position for a transit. It's a subtle effect, requiring extremely precise measurements, but it has led to the discovery of many exoplanets, including those that are Earth-sized or even smaller. These three methods, direct imaging, transit detection, and radial velocity, are the primary tools in the exoplanet hunter's toolkit. And while each is powerful, each has its own blind spots. Fomalhout B was a rare discovery because it was detectable with direct imaging, a method that isn't always effective. Its brightness and the distance from its star made it stand out, a ghostly figure in the cosmic dance. Most planets we find through direct imaging are large, gas giants like Jupiter, which are far enough from their stars that their light can shine through the veil. But Fomalhaut B was different, a mysterious anomaly in the sky, a fleeting moment that felt like a planet caught in the act of forming, or vanishing. But here's where the story gets more complicated. Fomalhaut B's discovery using direct imaging is part of what made it so remarkable, yet it also highlights the fragility of our methods. The planet's initial presence seemed so undeniable, so perfectly timed. And yet, as the years passed, Fomalhaut B began to fade from our sight, first becoming a more elusive shadow, and then, eventually, disappearing altogether. Was it always there? Was it a planet? Or was it something else entirely? Was it simply hiding from view, slipping into the fabric of cosmic dust? It's this uncertainty, this question of what we can truly know, that makes the hunt for exoplanets so mesmerizing. Every new discovery, every new observation teaches us more about the universe, and also how much we still have left to learn. We haven't seen Fomalhaut B disappear at all, but rather glimpsed a world on the edge of destruction, captured by the fleeting nature of the cosmic dance. Perhaps there are more ghost planets out there, hidden just beyond our reach, waiting to be discovered, or to slip away unnoticed, like so many other whispers in the dark. So, the question lingers. What does it really mean to discover a planet? Is it the shining beacon of certainty, or is it simply a momentary illusion, one we can barely hold on to before it vanishes once again into the stars? Perhaps the answer lies somewhere in between, where science, wonder, and mystery collide. Of course, one can never know for certain, as we have learned from the case of Fomalhaut B, even the data can lie at times. In the world of astronomy, data is sacred. It's the lifeblood of discovery, the thread we pull to unravel the mysteries of the cosmos. Every observation, every signal from the far reaches of space is treated with reverence, like a message from the heavens themselves. But data, as beautiful and profound as it is not infallible. Even the most carefully crafted instruments, designed to peer into the dark, vast unknown, sometimes whisper the wrong things. These are the false positives, when the universe presents us with a riddle that's more illusion than reality. The story of Fomalhaut B, the ghost planet, is one of those riddles. For years, this elusive planet was thought to be there, nestled in orbit around its star, captured in our telescopic gaze. But with the passage of time, as the data was revisited, questions began to swirl. Was it really a planet? Or had we misread the signals, allowing ourselves to be swept up in the thrill of discovery? Fomalhaut B's disappearance in the early 2010s was a reminder of how easy it is to fall victim to the seduction of data, to see patterns where none exist. Astronomical false positives are not new, and they are not rare. They are, in fact, part of the process. In a universe as vast and complex as ours, mistakes are inevitable. One of the most famous cases of a false positive in astronomy was the discovery of Planet X in the 19th century. Astronomers observed peculiar movements in the orbit of Uranus, and from these irregularities predicted the existence of an unknown planet beyond it. Years of searching followed, but no such planet was ever found. It wasn't until later that the inconsistencies were traced to the limitations of the instruments and the understanding of the time. The mystery was finally explained by the discovery of Neptune, not a phantom planet. Another well-known instance occurred in the 2000s with the supposed discovery of Nibiru, a planet said to be on a collision course with Earth. In reality, this was a misconception based on inaccurate readings, compounded by sensationalism. The idea took hold in the public imagination, but no actual evidence of such a planet ever surfaced. It was a mirage created by faulty data interpretation, fueled by conspiracy theories and fear. The discovery of glowing blue objects in distant galaxies provides another haunting example. In 2004, astronomers thought they had discovered a brand new type of star, a class that emitted an intense blue glow in wavelengths never seen before. But as they investigated further, they realized they had actually observed something much more mundane, a distant quasar whose light had been distorted by the gravitational lensing of a much closer galaxy. The initial interpretation was a dazzling but false positive, a fleeting moment of celestial magic that turned out to be something far less exotic. These examples remind us that the universe, in its infinite complexity, can often play tricks on us. The light that reaches our telescopes is the product of millions, even billions, of years of cosmic events. That light can be bent, distorted, and scattered by the very space it travels through. It's like trying to decipher a message that's been passed through 1,000 hands, each one altering it just a little bit. The result? A blurry, incomplete picture that we must carefully piece together, constantly double-checking, adjusting, and revising. The faintest tremor, the smallest flicker, can sometimes fool even the most seasoned astronomers. Fomalhout B's case is particularly interesting because it was a direct imaging discovery, a method that, unlike transit or radial velocity, requires capturing the light from a planet directly. Direct imaging is like trying to spot a firefly in a storm, with all the noise from the star's own brightness clouding the view. It's a challenging task, requiring cutting-edge technology and exquisite precision. The planet seemed so clear in the data, positioned just so against the vast canvas of space. Yet, with further observation, the question lingered. Was it really there? Or was it something else? Perhaps a cloud of dust, an illusion woven into the fabric of space. Did the data lie? Or did we lie to ourselves? The haunting beauty of Fomalhout B lies in its ambiguity. It's the kind of mystery that invites us to reach further, to look more closely. But it also reminds us that certainty in science is never guaranteed. In fact, uncertainty is part of the process. Errors and misinterpretations are part of how we learn, part of how we refine our methods and expand our understanding. The data, as sacred as it is always subject to the limitations of our tools and the inherent complexity of the universe itself. One might argue that this uncertainty is not a flaw, but a feature. It's a reminder that the search for knowledge is a journey, not a destination. With every mistaken observation, we refine our techniques, improve our models, and come closer to the truth. Each false positive, though initially disheartening, is a stepping stone, a small, necessary setback in the grand adventure of discovery. In many ways, the challenge of false positives reflects a deeper truth about our relationship with the cosmos. We are explorers in an unknown wilderness, navigating with only a few flickers of light to guide us. Every discovery, every piece of data, is like a footprint left in the sand, temporary, fleeting, and sometimes misleading. Yet, it's all part of the grand, beautiful puzzle. Perhaps that is the true lesson of Fomalhout B. It isn't about finding answers, but about learning to question, to look deeper, and to embrace the mystery. As we continue to reach for the stars, we must remember that not every spark we see is a new world. Some are the echoes of things long gone. But in that uncertainty lies something far more profound, a reminder that we are still learning, still uncovering the vast, mysterious depths of the universe. And who knows? Perhaps the next time we think we've found a planet, it will be something even more wondrous, something beyond our wildest dreams. So, as we look up at the stars, we must ask ourselves, is it possible that we're only seeing what we want to see? Or are we truly looking at the universe with clear eyes, ready to embrace whatever it shows us next? One thing is for certain, Fomalhout B changed the way humanity approached planetary science forever. In the dance of discovery, there are moments when the music falters, a misstep, a false note, a wrong turn, and suddenly everything we thought we understood is thrown into question. The story of Fomalhout B, the ghost planet that disappeared before our very eyes, is one of these moments. It wasn't just a curious case of mistaken identity, it was a profound turning point for planetary science. A reminder that even in the pursuit of certainty, we must embrace the possibility of the unknown, of the unexplainable. Fomalhout B's story didn't just rattle the scientific community, it reshaped it. The initial discovery, made in 2008 by the Hubble Space Telescope, was hailed as a triumph. A planet had been spotted around the bright star Fomalhaut, a beacon in the constellation Piscis Austrinus. It was the type of moment scientists dream about, the direct imaging of an exoplanet, a planet outside our solar system. It was exciting, groundbreaking, and, as it would turn out, premature. When the planet's existence was called into question years later, astronomers were forced to reckon with the fact that they had made a mistake. Fomalhaut B, as it turns out, was not a planet at all. Instead, it was likely a cloud of dust or debris, a fleeting illusion in the grand canvas of space. This revelation sent shockwaves through the field, forcing scientists to reconsider their methods, their tools, and their assumptions. One of the key lessons learned from this debacle was about the limits of observation itself. Space, as vast and limitless as it is also incredibly difficult to study. The instruments we rely on to peer into the heavens are not infallible. They are often like our own eyes, powerful, capable, but subject to the flaws of perspective. Fomalhaut B challenged the way astronomers thought about exoplanet detection. Until that point, direct imaging was hailed as a golden tool. The ability to photograph a distant planet directly was a feat once thought impossible. But Fomalhaut B's story made it clear that direct imaging, though invaluable, has its limitations. A planet can easily be mistaken for something else. A dust cloud, a faint reflection, an optical illusion. The line between reality and interpretation is often blurrier than we'd like to admit. This revelation has since catalyzed the development of new methods and technologies aimed at improving the accuracy of exoplanet detection. Astronomers began to refine their imaging techniques, pushing the boundaries of what is possible with current technology. One of the most significant advances has been the development of coronagraphs, instruments that block out the light of a star to make the planets orbiting it easier to detect. These tools allow us to peer deeper into the darkness, to capture images of faint worlds that would otherwise be obscured by the blinding light of their parent stars. The lessons learned from Fomalhaut B have pushed these technologies to new heights, ensuring that future discoveries are not as easily mistaken. But the changes weren't just technological. The Fomalhaut B episode also prompted a shift in the philosophy of planetary science. Before this discovery and its subsequent unraveling, there was a certain presumption in the scientific community that a planet is a planet once we see it. But Fomalhaut B's disappearance reminded us that observation doesn't always equal certainty. Data, while vital, can sometimes lead us astray. a shift in the scientific method followed, emphasizing greater skepticism and the need for verification, refinement, and second-guessing. No longer would astronomers take the data at face value. They would dig deeper, look harder, and question more. In a way, Fomalhout B became a symbol of the evolving relationship between science and uncertainty. It taught scientists that discoveries, whether they're about distant planets or the very fabric of our universe, are never set in stone. They are, instead, fleeting fragments of understanding, always subject to revision and reinterpretation. This is the beauty of science. It doesn't provide easy answers or neatly packaged truths. Instead, it asks us to look again, to question again, to evolve and grow in our understanding of the world around us. The disappearance of Fomalhout B also sparked a conversation about the very nature of planetary science itself. For decades, astronomers had relied on a few primary techniques to detect exoplanets: the transit method, watching for the subtle dimming of a star as a planet passes in front of it; radial velocity, measuring the tiny wobbles a planet causes in its star's motion; and direct imaging, taking pictures of the planets themselves. Fomalhout B challenged all of these. It wasn't a clean, clear-cut case of planetary discovery. It was a lesson in the complexity of these methods and a reminder that the universe is not always eager to reveal its secrets. In response, new methods have emerged, such as gravitational microlensing, which uses the bending of light around massive objects to detect distant planets. These advancements are not just technical improvements, they are conceptual revolutions. Each new method is a reminder that there is no single way to discover a planet, no one-size-fits-all approach. There are many paths to understanding, and they often lead to more questions than answers. Fomalhout B's legacy, in many ways, is a testament to the ever-evolving nature of scientific discovery. It's not just the mistakes we learn from, but the ways in which those mistakes reshape the very foundations of our understanding. We are, after all, explorers in the dark. We stumble, we trip, we sometimes get lost, but in the end, it's the journey that defines us. Fomalhout B didn't just teach us about the complexities of exoplanet detection. It taught us about the nature of exploration itself. At the heart of this debacle lies our technology, especially the telescopes that we relied so heavily on. Which raises the question, how do these telescopes tell the difference between data and dust? The things we cannot touch or see directly, but which exist in our universe nonetheless. Dust. To the untrained eye, it's just a speck on a window, a bit of dirt. But in the cosmic sense, it's something far more important. It's the fine mist of particles that drifts between the stars, the subtle trace of worlds that never were, or perhaps the echoes of worlds that could have been. In the case of Fomalhout B, it's the phantom signature of a planet that may never have existed at all. The discovery of Fomalhout B was a triumph of technology. It was supposed to be one of the great moments in astronomical history, a planet captured for the first time with a telescope's eye. Yet, as we soon discovered, what we thought was a planet was likely nothing more than a cloud of cosmic dust. But how could that happen? How could such an elegant illusion occur with something so ethereal fooling some of the brightest minds and most sophisticated tools we have at our disposal? The answer, it turns out, lies in how telescopes and algorithms interpret the data they gather, and how easily dust can mimic the appearance of a planet in the right circumstances. Telescopes, the tools we rely on to peer into the distant cosmos, are extraordinary in their own right. They can capture light from stars and planets billions of light years away. But the light they capture isn't always clear, crisp, or perfect. It's often distorted by layers of atmosphere, space-time bending, and the very light of distant objects themselves. It's up to advanced algorithms to help us make sense of that data, to turn the raw, noisy signals into something meaningful. Here's the catch. Not all light is equal. The way light behaves depends heavily on its wavelength. Wavelength is like the color of light, but not in the way we perceive it with our eyes. Some wavelengths of light, like infrared, pass through gas and dust with relative ease, allowing astronomers to peer deeper into the heart of galaxies or clouds. Other wavelengths, like ultraviolet or visible light, might get scattered or absorbed, making distant objects harder to detect. What does this mean for Fomalhout B? Well, it means that dust clouds can be seen more clearly in certain wavelengths. They can appear bright and clear, just like a planet would, especially in the infrared spectrum where cool objects like dust and debris shine most brightly. Think of it as looking through a fog. In one type of light, the fog is nearly invisible, but in another, it becomes so intense that you might mistake it for something solid, something real. This is exactly what happened with Fomalhout B. The cloud of dust that we thought was a planet reflected just the right amount of infrared light in just the right pattern to appear as though it was orbiting Fomalhaut. And that's not all. The distance between the telescope and the object being observed adds another layer of complexity. In the case of Fomalhout B, the object we were observing was extremely distant, about 25 light-years away. At such a distance, even the most powerful telescopes have trouble distinguishing between things that are close together. Objects like stars, planets, and clouds of dust can blur together in the telescope's field of view, making it even harder to tell what's what. The algorithms that analyze the data must make decisions about what features belong together and what features do not. But these algorithms are not infallible. They work on patterns, data points that match known characteristics of objects like planets or dust clouds or debris. When the data doesn't match anything clearly, they try to make their best guess. But guess wrong, and you end up with a mistaken identity, just as we did with Fomalhout B. Then, there's the resolution of the data. In order for a telescope to distinguish a planet from a dust cloud, the resolution of its images needs to be incredibly high. However, even with cutting-edge instruments like the Hubble Space Telescope, the images we receive from space aren't perfect. There's always a bit of blur, a grainy quality to the data. That's why it's often up to sophisticated algorithms to analyze the pixels and determine what's really there. But just like an artist whose brush strokes are slightly off, a little blur can lead to a whole different interpretation of the picture. It's in this imperfect resolution, in the blurry lines between what we think we know and what's actually out there, that the illusion of Fomalhout B was born. This brings us to the deeper truth about how we explore the universe. Our tools are sharp, but they are not flawless. They are refined, but they are not perfect. We look at the stars with our telescopes, and we interpret the data with algorithms, but in a way, we are still guessing. With Fomalhout B, our tools told us one story. The data seemed to say that a planet was there, orbiting a distant star. And yet, as we looked closer, much closer, with more time, more instruments, more thinking, we realized the story was more complex. The story wasn't about a planet at all. It was about a cloud, a fleeting cloud of dust and gas, tricking us with its brightness, its shape, its position in space. The disappearance of Fomalhout B, if that's what we can call it, reminds us that even in the era of sophisticated telescopes and AI-driven algorithms, our understanding is still only as good as the information we can gather. And sometimes that information is messy. It's incomplete. It's a puzzle with pieces that don't always fit together neatly. So, what does that mean for us, the stargazers, the explorers? It means we must learn to live with ambiguity. We must be willing to admit that, just as much as we seek answers, we must also embrace the mystery. Perhaps, after all, it is the unknown that makes the pursuit of knowledge so thrilling. What if the dust clouds are not just mistaken planets, but the very things that hide the secrets of the universe, waiting for us to learn how to read them properly? If even our telescopes can make mistakes, how can we improve them to account for these errors? That is where the James Webb Telescope comes in. The James Webb Space Telescope is a marvel of engineering. an eye that sees farther than anything before it, reaching into the infrared heart of the universe with the precision of a master painter tracing every detail of a canvas. This telescope promises to carry our gaze beyond the veil of mystery that Fomalhout B unfolded, but what lessons has its predecessor's failure, Fomalhout B, taught us about the delicate art of cosmic observation? Fomalhout B was a lesson in the deceptive simplicity of dust. It wasn't a planet, it was a mirage, an illusion shaped by the very materials that litter the galaxy. But what makes the James Webb Space Telescope poised to avoid these illusions, to see more clearly into the depths of space where dust clouds and planetary bodies interlace like a cosmic dance? The answer lies in its design, its capabilities, and the methods we've refined over decades of astronomical exploration. First, let's talk about how the James Webb Space Telescope is built to face exactly this kind of challenge. Fomalhout B slipped through our fingers not because our telescopes were blind, but because they didn't have the kind of detailed resolution needed to distinguish between a planet and a cloud of gas and dust. James Webb Space Telescope, however, has an infrared sensitivity that pushes beyond what the Hubble Space Telescope or any previous instruments have been capable of. Infrared light allows the James Webb Space Telescope to see what's hidden beneath the thick veils of dust and gas that obscure other instruments. It allows us to look directly at the heart of a cloud and see if it's the fiery surface of a planet or the cooler, more diffuse nature of debris. In other words, James Webb Space Telescope's infrared capabilities are like a new set of eyes that can see the finer, more subtle differences in objects that other telescopes might misinterpret. Imagine trying to find a single star in a dense fog with a foggy window. You'd need a lens that clears the mist, one that can differentiate between a light source and the fog itself. James Webb. Space telescopes' advanced sensors are that lens, finely tuned to distinguish between the scattered light of dust clouds and the steady, unmistakable glow of a planet. Yet, it's not just infrared sensitivity that makes the James Webb Space Telescope special. It's also the way it uses its tools to gather data. James Webb Space Telescope doesn't just snap pictures like a casual tourist. It uses a variety of detectors that work together to create a multi-dimensional map of the sky. It's like using a painter's palette of colors to capture the full spectrum of a scene. By looking at multiple wavelengths, James Webb Space Telescope can better understand the structure of what it sees, whether it's a dusty cloud, a newborn planet, or the surface of a distant exoplanet. But there's still something even more remarkable about the James Webb Space Telescope: its ability to detect and analyze the fine details of a distant world. The farther we look, the fuzzier things get. That's true both in terms of distance and time. When we look at something billions of light years away, we are seeing it as it was, not as it is. For a long time, Fomalhout B was that mirage, a vision of a planet that no longer existed in the way we thought it did. James Webb Space Telescope, however, has the ability to correct some of that distortion, not just by gathering more light, but by studying the light itself, dissecting it into a rainbow of information, decoding the subtle signatures that tell us if something is real or simply an illusion in the vastness of space. As we look at future observations, especially when James Webb Space Telescope turns its gaze towards exoplanets, planets outside our solar system, we know that it will avoid many of the pitfalls that befell our earlier observations. By using more advanced algorithms to process the data, by combining the power of both space and ground-based telescopes, and by applying more refined techniques to study the atmospheres, surface compositions, and light emissions of these objects, James Webb Space Telescope will offer us a clearer, more definitive picture of the universe. This, however, isn't just a technological triumph, it's a philosophical one as well. Fomalhout B reminds us that the universe is full of tricks, full of illusions that can mislead even the most careful observer. Just as light can bend and twist in space, so too can our perception of what we're seeing. The lessons we've learned from that ghostly planet will help us understand how to look more carefully at the stars, how to interpret the data with caution and reverence, and how to appreciate that sometimes, even in the cold vastness of space, what we think we see may not be the whole story. And yet, this is what makes the search for planets, for life, for meaning in the cosmos so endlessly fascinating. We are chasing shadows, yes, but in chasing them, we learn to see the light more clearly. Each new discovery, each misstep, and each triumph brings us closer to understanding not just what is out there, but how we can trust the tools we use to observe it. As James Webb Space Telescope continues its journey, the promise is clear. The telescope's gaze will pierce through the darkness, shedding light on what's hidden, what's real, and what's perhaps still only a figment of our cosmic imagination. But with each step, each new revelation, the question remains. As we peel back the layers of dust, gas, and light, what truths are we still missing? And how much of the universe is yet to be uncovered? More importantly, Fomalhout B didn't just lead to improvements in technology. Rather, it changed our perception of science and astronomy for the better. There is always something to be learned. We build our understanding step by delicate step, using the best tools at our disposal. But even in the pursuit of knowledge, there are moments where the universe, with its vastness and its strange beauty, pulls the rug out from under us. Fomalhout B is one such moment, a cosmic trickster that defied expectations and taught us that even the most sophisticated scientific minds can be led astray. Fomalhout B was, for a time, a shining beacon of discovery. It had all the hallmarks of a planet: its position in the Fomalhaut system, its apparent motion, and the way it reflected light. It was an object wrapped in promise, whispering of new worlds, perhaps even the possibility of life, beyond the reaches of our familiar solar system. But when we looked closer, when we peered through the lens of new technology, that promise unraveled. What we thought was a planet turned out to be something altogether different: dust, a cloud of particles caught in the gravitational dance of the Fomalhaut star, giving the illusion of a planet in motion. It was like a mirage in the desert, clear from a distance, yet elusive upon approach. And this discovery, this sudden unraveling, has served as a reminder, both humbling and enlightening, that science is a journey, not a destination. In many ways, Fomalhout B acts as a cautionary tale for the scientific community, one that speaks to the very nature of our observations and conclusions. As advanced as our telescopes and algorithms have become, they are still, at their core, interpreters of light. Light that travels across vast distances, bending and scattering in ways that are sometimes as mysterious as the universe itself. Just as a single misstep on a rocky path can lead us astray, so too can a misinterpretation of the data we gather lead to a false understanding of what we are seeing. Consider the grand task of exploring the universe as if it were a massive, intricate jigsaw puzzle. Each piece is a fragment of light, data, or theory, an incomplete but essential clue. We build a picture over time, slowly adding new pieces, refining our understanding with every step. But occasionally, a piece will seem to fit perfectly into place, only for us to discover later that it was the wrong one altogether. Fomalhout B was one such piece. Its shape and location fit what we expected, but its true nature was hidden in the folds of space and dust, tricking even the sharpest minds. This lesson is not just about Fomalhout B, but about the scientific method itself. We place our trust in the tools we create: telescopes, algorithms, and models. And for the most part, these tools serve us well, guiding our understanding of the universe. But science is not about absolute certainty. It's about constant refinement, questioning, and re-evaluating what we think we know. It's a pursuit of truth, but always with the understanding that truth can be slippery, elusive, and often subject to change. Fomalhout B reminds us that even with the best technology, we are still human. and our eyes, whether biological or mechanical, can be deceived. The scientific process is not a straight line, but a winding road. We often must backtrack, reevaluate, and adjust our conclusions as new evidence emerges. The universe, it seems, loves to keep us on our toes, showing us just enough to keep our curiosity piqued, but never enough to fully grasp it. And yet, despite the sting of such a revelation, there is something profoundly beautiful in this lesson. There is beauty in the humility of discovery, in the realization that we are not infallible. For in that humbling, we find the fuel for further exploration. It's in the mistakes and missteps that we grow, that we refine our questions, that we sharpen our instruments and our minds. Every discovery, even the ones that disappoint, adds to the rich tapestry of our understanding of the cosmos. Fomalhout B's story doesn't end with disappointment. It ends with a challenge. It calls us to look more carefully, to ask more questions, and to hold even our brightest revelations in a gentle embrace, knowing that they too may one day be replaced with something deeper, something truer. In this way, Fomalhout B has become more than a cautionary tale. It's a symbol of the tension between knowledge and uncertainty, a reminder that science is not about achieving perfection, but about constantly chasing the horizon of understanding. For each discovery, we uncover not just answers, but more mysteries. It's like standing on the edge of a vast, uncharted sea, where every wave that comes to shore reveals both beauty and enigma. So, what is it that we ultimately learn from Fomalhout B? Perhaps it is the importance of patience, of recognizing that the pursuit of knowledge is a long, winding path, where even the most carefully constructed conclusions can dissolve with a single moment of new insight. Or maybe it's the reminder that the universe is more intricate, more subtle than we can ever hope to fully understand. It hides its secrets behind layers of dust, light, and time, and sometimes it tricks us into thinking we've found something solid, only to show us that there's always more to uncover. In a way, the universe itself can deceive us. The universe speaks, but not in the way we might expect. Its language is one of illusion, one of moments that flicker like distant stars on the horizon, disappearing as quickly as they appear. Fomalhaut B, the ghost planet that vanished, is a perfect example of this cosmic deception. How many times have we looked up at the night sky and thought we saw a familiar shape in the stars? How often have we felt sure that something was there, only for it to elude our grasp the moment we turned our attention to it? It's easy to forget that the very nature of space, light, and time can trick the mind, weaving illusions that we chase with all the zeal of explorers charting unknown lands. Space, after all, is not the static, predictable domain we often imagine it to be. It is wild, unpredictable, a place where the rules of reality can bend and twist like light itself. What we see is not always the truth. We can observe, measure, and calculate until our instruments break, but the universe has a way of revealing its truths in the most unexpected of ways. This isn't just science fiction. This is the way the cosmos works. The truth hides behind layers of dust, light, and space-time, always just out of reach. Fomalhaut B was thought to be a planet, a shiny, distant world revolving around its star. It fit the expectations. The image captured by the Hubble Space Telescope seemed so certain, so clear, like a drop of water held in the universe's palm. But as the years passed and as technology advanced, that image of a planet slowly began to dissolve. What we had been looking at wasn't a planet at all. It was something far more ephemeral, dust, a cloud of particles caught in the gravitational pull of its star, reflecting light in such a way that it appeared solid, but was, in fact, fleeting and insubstantial. This illusion is not unique to Fomalhaut B. It's something that happens time and time again in the realm of astronomical observation. The universe is a master of misdirection, and we are but its willing audience. Take, for example, the way light travels across the cosmos. Light does not simply move in straight lines. It bends, it warps, it dances with the fabric of space-time. And when it reaches us, flickering over millions of years, what we see may not be the object itself, but its ghost. This is the very nature of the universe. It deceives us. And it's not because it wants to mislead us. No, the universe is simply indifferent. It doesn't care about our attempts to measure and categorize it. It is wild and untamed, a cosmic forest that grows and shifts with every passing moment beyond our understanding. And yet, in our search for meaning, we continue to chase these shadows. Light itself is one of the greatest deceivers. Think about it. Light travels through the vastness of space at a speed so immense that it takes years, sometimes thousands or even millions of years, to reach us. What we are seeing, then, is often not the present moment, but the distant past. The light that reaches us from distant stars has traveled unimaginable distances, bending through the very fabric of space-time itself. What we see in the night sky is not what exists now, but what once was. A moment frozen in time, a moment that has long since passed, but one that we still try to understand and make sense of. This is the illusion. And it's not just in the stars, but in the very way we perceive everything around us. Our minds are wired to search for patterns, to find order in chaos, to connect dots where there may be none. In this search, we often create illusions of our own, seeing faces in clouds or patterns in random numbers. The universe, in its vastness, is much the same. It offers us glimpses of something more, but always just out of reach. And we, in our fascination, fill in the gaps with our own stories, our own explanations. Even our most advanced technologies can be deceived. Telescopes, instruments of incredible precision, can sometimes fall prey to the universe's tricks. The Hubble Space Telescope's image of Fomalhout B is a perfect example of this. It was an image of a planet, until it wasn't. It was a reflection of something that, for a brief moment, appeared real, but was not. This is the nature of science. It's not about certainty, but about refining our understanding, about peeling back layers of illusion to reveal the deeper truths beneath. But how much of the universe is illusion, and how much is reality? How much do we truly know, and how much do we imagine? For all our advances in technology, for all the data we collect and analyze, how much of it is just us looking at the ghosts of things that were, or might have been, but are no longer? In the end, the story of Fomalhout B is not just about a vanished planet, but about the very nature of our search for knowledge. It's about the way we chase after certainty, only to find that the universe offers us mystery instead. And perhaps that's the beauty of it all, the realization that the more we know, the more we understand how little we actually understand. Every answer leads to more questions. Every discovery opens the door to more mysteries. So, as we continue our journey through the stars, chasing light and shadows, we must ask ourselves, how much of what we see is truly there? And how much is just the universe playing its games with us? It is also important to realize that calling Fomalhout B a debacle is unfair. Sure, we did make a mistake, but in doing so, we learned so much more. Not only did we correct our misguided notions, we learned an important philosophical lesson as well. Isn't there something beautiful about the idea that we were once wrong about something so vast, so distant, that it might as well have been a dream? A shimmering, ghostly planet, the kind of thing you only read about in ancient mythologies, or perhaps in a science fiction novel, suddenly revealed to our eyes through the cosmic lens of technology. Fomalhout B, the planet we once thought we discovered, wasn't a planet at all, but a cloud of dust, a trick of light, a mirage in the desert of space. And yet, there is a kind of poetry in that illusion. Imagine this. For a moment, just one fleeting moment, the human race thought it had found another world. There it was, bright and shiny, drifting along in the cosmic sea, captured by our most powerful telescope. We named it, we catalogued it, we pinned it to the map of the universe, and as quickly as it appeared, it vanished. A cloud, a trick, a glimpse of something that might have been, but wasn't. But does that take away from the beauty of the discovery? In many ways, no. There's something strangely poetic about this fleeting moment of wonder. How many times in our lives do we reach out, grasping for the unknown, only to find that what we thought was there was never meant to be ours? Fomalhout B, like many things in the universe, was a fleeting dream that shimmered briefly before disappearing into the black void. And maybe that's where its beauty lies. It's easy to romanticize something we never truly touched, never fully understood. There's a purity in the impermanence of the moment, the idea that the universe is too vast and too wild to be fully comprehended. The discovery of Fomalhout B, even if it wasn't what we thought it was, reminds us that the journey of exploration is not about finding solid answers, but about experiencing the wonder of the search itself. In that brief moment when scientists first laid eyes on it, they were filled with the same awe that stirs in us when we look up at the night sky and wonder what's out there. It wasn't the planet they expected. It was something more fleeting, more elusive, a cosmic reflection that felt almost like an invitation. The universe, with all its immensity and mystery, seems to be constantly teasing us. It presents something that feels real, only to pull it away before we can fully understand it. But isn't that what makes this all so beautiful? That in our pursuit of knowledge, we are always chasing something just beyond our grasp? It's like trying to catch starlight in our hands. Impossible, but endlessly captivating. For all our advancements, for all our telescopes and computers, we still don't have the answers. We can only reach out, make our discoveries, and marvel at what we learn in the process. The rest, the elusive truth, the things that remain hidden, becomes part of the mystery that keeps us coming back. Fomalhout B serves as a gentle reminder of this, a symbol of the delicate dance between knowledge and mystery. It was never a planet, but it was something that held our gaze, even if just for a short time. It made us dream of worlds beyond our own. And in that dream, in that brief period of illusion, we were reminded of the infinite possibilities that still lay ahead. There's something poetic in the fact that we, as humans, can make mistakes in the pursuit of something as grand as a new world, yet still find beauty in the mistake itself. What we thought was a planet turned out to be dust, yet that dust, that cloud, captured something larger than just a planet. It captured our imagination. It reminded us of the fragility of our understanding and the fleeting nature of truth itself. The discovery wasn't a failure. It was a lesson, a cosmic whisper telling us that even in our brightest moments of clarity, there is always the possibility of illusion. And isn't that the essence of discovery? It is the recognition that with every answer we uncover, new questions emerge, like ripples in a pond that stretch out endlessly. The more we know, the more we understand how little we can truly grasp. So, maybe there's something more profound in this mistaken discovery than we initially thought. It isn't about the planet that wasn't. It's about the process of seeing, of reaching out into the great unknown and finding something, anything, that brings us closer to understanding the vastness of existence. Fomalhout B has taught us that there is a certain kind of magic that resides in the unknown. It isn't the sharp, crisp clarity of discovery, but rather the faint glow of a distant star, unreachable, mysterious, almost intangible. It's the quiet hum of something just beyond our grasp, pulling us toward it without telling us what it is. In many ways, this is the heart of science, the endless dance between certainty and mystery. And it's this dance that makes science so irresistibly beautiful. Think back to Fomalhaut B, the ghost planet that captured our collective imagination. For years we believed in it. We saw it in the stars, glowing brightly, perfectly placed in the vastness of space, a world in the making. We called it a planet, and we mapped its orbit with the precision of scientists driven by wonder. We saw evidence, and we believed. Yet, just as quickly as it appeared, it vanished. Not because the universe had deceived us, but because we hadn't fully understood the clues it left behind. What we thought was a planet was, in fact, not a planet at all. It was dust, an illusion formed by the delicate interplay of light, distance, and the limitations of our technology. This is where the beauty of science lies. In the pursuit of truth, we are constantly challenged by what we do not yet know. In the chase for answers, we often encounter more questions than solutions. And isn't that the essence of wonder? It is not the certainty of what we know that ignites our curiosity. It is the uncertainty of what we don't. It's easy to look at the disappearance of Fomalhout B and think of it as a mistake, a failure, a misstep. But to dismiss it in such a way would be to ignore the profound power of the unknown, because it is the uncertainty that drives us to continue searching. If we already had all the answers, if the universe were as clear as a polished mirror, would we still be so captivated by it? Would we still reach out with that childlike wonder, hoping for something beyond the horizon? In many ways, it is the questions, those unanswered, elusive mysteries that fuel the fire of discovery. We look up at the stars and ask, what is out there? We peer into the deep expanse of the universe and wonder if we are truly alone. The more we learn, the more we realize how little we truly know. And that is not something to fear. It is something to celebrate. Because in that space between knowledge and ignorance, there is an entire universe waiting to be explored. Take, for example, the incredible tool that allowed us to see Fomalhout B in the first place, the Hubble Space Telescope. It provided us with images of a distant star, and in those images, we thought we saw a planet. But the telescope, brilliant as it is, only showed us a snapshot of the universe, one that was shaped by its limitations. The more we learn about how light bends and how data is processed, the more we realize that our understanding of the cosmos is forever being shaped by the tools we use to explore it. The instruments of science, like the eyes of a painter, filter the world through a lens that is both powerful and flawed. And yet, it is through that lens that we see, and it is through that lens that we learn. In this way, Fomalhout B teaches us something important about science. The pursuit of knowledge is not a straight path, but a winding road full of false leads and detours. It's in the moments when we think we've found an answer that we are reminded of how little we know. And in that reminder, there is a profound truth. The beauty of science is not in its certainty, but in its endless potential for discovery. It is in the gaps, the questions, the things we don't yet understand, that we find the true power of the universe. Science is often framed as a quest for truth, and in many ways, that's exactly what it is. But what if the pursuit itself, the act of seeking, is just as important as the answers we find? In a way, the unknown is where we live. It is the space in which we exist, and it is where the magic happens. The universe is not something we can fully comprehend, not in the way we would like to. It is too vast, too intricate, too strange. And yet, that is what makes it so captivating. Each discovery opens the door to another mystery, and each answer leads to another question. There is no final destination, only the journey. Fomalhout B, like many things in the cosmos, was not what we thought it was. It slipped through our fingers like a wisp of smoke, leaving behind only the faintest trace of what could have been. But in that trace, there is a lesson. It reminds us that what we see is not always what is, and it tells us that the universe, in all its complexity, is not something to be mastered. It is something to be wondered at, to be embraced with humility and awe. So, the next time we encounter the unknown, the next time we stumble upon a mystery that defies explanation, let us not shy away. Let us celebrate it. For it is in that uncertainty that we find our true place in the cosmos. After all, what would the stars be without their darkness? And what would science be without its endless questions? In the vastness of space, where so much remains hidden from our eyes, isn't it the pursuit of the unknown that defines our place in the universe? What if the beauty of the cosmos is not in the answers we find, but in the questions that continue to unfold before us? And the biggest question that remains here is whether or not Fomalhout B ever really exist. What does it even mean to exist? In our everyday lives, it's something so basic, so ordinary, that we rarely stop to think about it. We live in our bodies, we speak, we feel. Existence is what we breathe in and out, something we take for granted. But when we extend that question to the cosmos, when we ask if something out there ever really existed, it becomes far murkier. Take Fomalhout B, for instance. This ghostly planet that captured our imaginations and then slipped away as fleeting and insubstantial as a dream. Did it ever really exist? Or was it simply a mirage painted by the limits of our own perception? The concept of existence in astronomy, much like existence in philosophy, is layered, complicated, and often elusive. We can point to stars, to planets, to moons, and say, that is real. But is it? The universe is so vast, its laws so alien to our daily experience, that even the most solid objects in the sky are subject to change. Things are born, evolve, and disappear on a scale we can't even begin to comprehend. So, when we discover something like Fomalhaut B, a planet orbiting the star Fomalhaut in the constellation Pisces, and then watch it vanish from our observations, we must ask ourselves, was it ever truly there? Or was it simply an illusion, a temporary flash in the cosmic sea? Fomalhaut B was first identified in 2008, a faint but tantalizing speck of light. It was placed in the spotlight as one of the most exciting exoplanets ever discovered, proof that worlds existed beyond our own solar system, waiting to be explored. Astronomers hailed it as the next great discovery, the next grand step in our understanding of the universe. But as quickly as it emerged, Fomalhaut B began to fade. The Hubble Space Telescope had caught glimpses of it, but the more we looked, the more we realized it wasn't a planet at all. The images we had were not of a solid planetary body, but of dust and debris scattered in the space between us and the distant star. What we had seen wasn't the planet we had hoped for, but the illusion of a planet, a trick of light and shadow, a cosmic sleight of hand. So, if we've been deceived by the universe itself, does that mean Fomalhaut B never truly existed? The question is as puzzling as the planet itself. Existence, in the realm of the cosmos, is not something that can be easily defined. Objects in space do not live in the same rigid framework of time and certainty that we do. Stars burn brightly for billions of years before fizzling out. Galaxies collide, and black holes swallow everything in their grasp. So why should a planet be any different? Perhaps Fomalhaut B existed in the only way that matters in the universe, briefly, fleetingly, and as a product of the vast cosmic forces that created it, only to disappear just as mysteriously as it had appeared. In that sense, its existence was very much real, even if it wasn't what we imagined. What Fomalhaut B teaches us is that reality, as we understand it, is far more malleable than we might like to think. Our perceptions of the universe, of planets, stars, and galaxies, are often based on data and tools we've built, and these tools are far from perfect. The telescope, for instance, is a creation of human ingenuity. It allows us to peer into the deep expanse of space, but it also has its limits. It can't see everything. It can't hear the faint whispers of cosmic dust that swirl between the stars, and it can't capture the full complexity of the universe. Fomalhaut B might not have been a planet in the traditional sense, but it existed in the sense that we saw it. It existed because we dreamed it into being, and in that way, it was as real as any other celestial object. But the story of Fomalhaut B isn't just about the fleeting nature of existence. It's also about the role of human perception in shaping the universe we think we understand. Our minds are constantly trying to make sense of the cosmos. We impose our human concepts of being onto a universe that is far more strange and unpredictable than we could ever imagine. In our quest for understanding, we shape the universe to fit our expectations, and in doing so, we create our own illusions. Fomalhout B was one of those illusions, a creation of our scientific imagination, a reflection of our hopes and desires to find something out there, to discover something grand. This raises an important question. If existence is so subjective, so dependent on how we see and interpret things, then what can we truly say about the nature of reality? Is the universe simply a collection of objects waiting to be defined, or is it something far more fluid, more ephemeral than we realize? The idea that we can discover planets, stars, or galaxies presupposes that these things exist independently of us, that they are out there, waiting for our gaze to settle on them. But what if the universe isn't so easily defined? What if it's not about discovering what is, but about creating meaning from the mystery that surrounds us? Fomalhout B may have vanished from our sight, but the mystery it left behind is no less potent. The question of its existence and the broader question of what it means to truly exist in the vastness of space reminds us that we are still, in many ways, blind explorers, trying to understand a universe that exists on its own terms. Perhaps this is the true beauty of the cosmos. It is not something to be pinned down, something to be defined. It is something to be wondered at, something that exists in our imagination as much as it exists in the stars. So, when we look up at the night sky and think about Fomalhout B, we are reminded of the fragile nature of existence. We are reminded that the universe does not play by our rules, does not care for our need for certainty. And maybe that's okay. Maybe the greatest truths are those that elude us, those that exist just out of reach, like the stars themselves, always present, always flickering, but never fully within our grasp. The question isn't whether Fomalhout B ever really existed. The real question is, does it matter? As we piece together this cosmic riddle, we arrive at certain concrete and fascinating conclusions. We did see something remarkable, even if it wasn't a planet. It's a quiet thing, this search for answers. We peer into the infinite blackness of space, convinced that somewhere out there, a perfect truth is waiting for us to find it. We believe that if we just look hard enough, we will uncover the universe's deepest secrets, that the stars will finally reveal their hidden stories. But what if we've been looking in the wrong place all along? What if, when we thought we glimpsed Fomalhout B, we weren't seeing a planet at all, but something much more elusive? For years, Fomalhout B haunted the edges of our collective imagination. It wasn't just a planet, it was a promise, a hint that perhaps we were getting closer to the answers we've been yearning for. Discovered by the Hubble Space Telescope in 2008, Fomalhout B seemed to shimmer in the dark, a faint beacon in the night, as if whispering, "Here I am." A planet orbiting a distant star, somewhere in the far reaches of our galaxy. It was a symbol of our relentless drive to understand, to explore, to name, and to claim our place in the cosmos. But as quickly as Fomalhout B appeared, it vanished. First, it slipped from the grasp of the Hubble Space Telescope's watchful eyes. Then, after years of careful observation, it was revealed that what we had seen, a bright spot, a moving object, a possible exoplanet, wasn't really a planet at all. It was, in fact, a cloud of debris, a collection of cosmic dust and gas, a mirage, no more tangible than the moonlight on a distant lake, vanishing when we try to grasp it. And yet, here we are, still mesmerized, still intrigued. If Fomalhout B wasn't a planet, then what was it? And why does its fleeting existence still haunt us? The answer, perhaps, lies not in the planet itself, but in our desire to find something, anything, to hold on to in the vast unknown. Maybe what we were truly seeing all along was not a distant world, but a reflection of ourselves. It is, after all, a uniquely human thing to search for meaning in the cosmos. We reach out, desperate to make sense of the silence, to find answers in the emptiness. Fomalhout B, in its brief and tantalizing appearance, became a symbol of that search, an embodiment of our collective yearning for discovery. But the truth is, the universe doesn't owe us answers. It doesn't care whether we find them or not. In our attempts to define and label everything we see, we may be forgetting that some mysteries are meant to remain unsolved, like the flickering stars themselves. We project our desires onto the universe, hoping it will reflect our longing for certainty, for purpose. And when it does not, when it shatters our illusions, we are left to confront the possibility that the answers we seek may never be found. Perhaps that is the ultimate riddle that Fomalhout B leaves us with. In our search for meaning, have we misunderstood the nature of the search itself? Maybe we were never meant to find a planet, to confirm the existence of a distant world. Maybe we were simply meant to ask the question, to wonder, to acknowledge that we do not have all the answers, and that this uncertainty is where true exploration begins. The disappearance of Fomalhout B doesn't diminish its significance. Rather, it deepens it. For in its vanishing, it becomes something greater, a symbol of the impermanence of our knowledge, a reminder that the cosmos is far more mysterious and profound than we could ever imagine. What if the search, the act of reaching out into the darkness, is what matters most? What if, in the end, it's not about the planets we discover or the mysteries we solve, but the questions we continue to ask? In this sense, Fomalhout B never truly disappeared. It exists in the quiet corners of our curiosity, in the questions we dare to ask, and in the wonder that still stirs within us when we look up at the night sky. Perhaps the true discovery isn't about finding a planet at all, but in realizing that the universe, in its infinite complexity, will always leave us just a little bit lost. And isn't that the beauty of it? That, for all our science and all our telescopes, there will always be things beyond our reach. Things that exist, not in the form of planets or stars, but in the space between the stars. Things that reside in the questions we keep asking and in the mystery that will never cease to captivate us. So, what did we truly see when we looked at Fomalhout B? Maybe we saw ourselves, reaching out, stretching toward the unknown, trying to make sense of a universe that is as beautiful as it is unknowable. And perhaps, in that act of searching, we found something more profound than we ever expected.